We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking. We're hacking all the things. All right, so let's go ahead and talk about what we're going to be covering today. So let's see. Let me grab the overlays, and then let's go over to the Reddit. So every week over at HackerFrogs, we have a list of our schedule, the topics we're going to be covering for each one of these live streams, and we typically go through 4 topics in each live stream. So today is November 7th. It is Friday, and we're doing coding first. We're going to be doing some Leetcoding. Leetcode is a very popular website for learning how to solve specific coding problems, and we've been working through a bunch of easy challenges over there to better learn how to do some programming in Python, which is our favorite programming language. So that's the first topic of today. And in the second topic, we're going to be covering HackerFrogs AfterSchool Digital Forensics, session number 6. So HackerFrogs AfterSchool is our educational program, and we've been working through digital forensics. And today we're going to be talking about how to take a look at disk image forensics using the autopsy program. So that's going to be over at TryHackMe. If you don't have an account at TryHackMe, you can make one over there, and then we can all solve those rooms together. Okay, so for the third topic, we're going to be doing a demo on binary hacking. So binary hacking is something I've been trying to learn a lot more about lately, but today we're going to be demonstrating one of the challenges over at PicoCTF.org, which is another really great cybersecurity education platform. And that's going to be in the third hour of today's stream. In the fourth and fifth hours, we're going to be doing, well, we're going to be changing up our schedule. It says all of cyber, software hacking challenges, but we're actually going to be doing the network over at Standoff365, which was a cybersecurity platform that was introduced to me a couple of weeks ago. And it's pretty good. It's a pretty good platform if you're an intermediate or advanced student of network pen testing. And we've been working through a very large network over there and trying to figure out all of its secrets. So let's so without further ado, let's start into our first topic, which is going to be programming with Leetcode. Let me put 60 minutes on the clock, and then we can get going. Loki says, Loki Abu says, hello, Mr. Hat. Hello, Loki Abu. Nice to see you here. And how are you doing? All right, so we've got 60 minutes on the clock. We're going to be doing some Leetcoding challenges. And let's choose the challenge we're doing today. So let's do, I don't know, let's just do this one. It's called Indivisible and Non-Divisible Sums Difference. More math stuff. Well, good thing we're doing it through programming languages, so I don't have to do the math myself. If anybody's interested in taking a look at this challenge in particular, this is, I think this should be the link right here. And if you have an account over at Leetcode, you can do this challenge yourself. So for each one of these challenges, what we like to do is we like to create a walkthrough for these. Loki Abu says, I'm good, pleased to meet you. No problem, no problem. Yeah, I hope you can learn a lot of stuff over here. We're just going to be doing a lot of different cybersecurity topics. We're going to be starting off with some programming, of course. Okay, so let's create a new walkthrough file over on our GitHub. And let's see, it's going to be an MD file. It's for Markdown. And this challenge is called Divisible and Non-Divisible Sums. Okay, so for each one of these challenges, we want to record a couple of things. So the first thing we want to record is the URL of the challenge. The second thing we're going to cover is the concept. We need to understand the challenge. And since this is Leetcode, that comes with the description, we'll also include the description of the challenge. And finally, we'll provide the code the solving code. Okay, Locabu says, I've kind of climbed the cybersecurity ladder and I'm doing more managerial stuff the past 2 years, so I'm very rusty with fundamentals. It really depends on what you define as fundamentals. If you're doing a managerial role, I understand that you probably don't have as much time on keyboard, doing using all the tools and stuff, because managers are more about managing people, but it's good to know exactly what's going on in the first place. Okay, so let's go ahead and grab the URL of this challenge. Oh, GRC, of course. So GRC is governance something and compliance. Well, I forget what the R stands for. Government something and compliance. But let's see. So we're just creating our, risk and compliance. Okay, no worries, no worries. Thank you, thank you. Okay, the description for the challenge. Let's go ahead and read that right now. We can drag these windows around. Okay, so this is divisible and non-divisible sums difference. You are given positive integers n and m. Define two integers as follows: num1, sum of all the integers in the range 1 to n, both inclusive, that are not divisible by m. Number 2 is the sum of all integers in the range 1 to n, both inclusive, that are divisible by m. Okay, so we need to return the integer num1 minus num2. Num1 minus num2. Okay, well, let's take a look at the examples. So example known is input n equals 10, m equals 3. Output is 19. In the given example, in the integers in the range 1 to 10 that are not divisible by 3, it's these numbers. Okay, and num1 is the sum of those integers, equals 37. Numbers in the range 1 to 10 that are divisible by 3 are 3, 6, 9. Number 2 is the sum of those integers, which is the number 18. We return 37 minus 18 equals 19 as the answer. Okay, so I think I kind of understand what's going on, but I'll just copy the description over to the GitHub. And then we can get started. Okay, so the description is here. And then let's go ahead and get started with our coding our solution. Okay, so what we're going to be doing while we're solving these challenges is we're going to have two windows open. So there's going to be one window which we use for running the code, and the other window is going to be for writing the code. So let's make a new temp directory. And let's go into that same directory here. So temp. Okay, I'm working in the temp directory because eventually I want all these files to disappear. So that's why we're working inside of the temp directory. But anyways, we'll create this new file inside of Python, and we'll call it divisible non-divisible, or div non-div. So let's see, nano-l div non-div.py. Okay, so we've got our code editor over here on the right-hand side, and on the left-hand side, this is going to be where we run the code. So let's go ahead and get started. So over here, we've got our class for the solution. I'm just going to copy that, and then I'm going to copy it over to our coding window. Coding window is here, and before we start creating code inside of the solution class over here, what we're going to do is we're going to create a solution. So solve equals an object in the solution class. And then run is going to be solve.difference of sums. And we need an n and an m in this case, and an n and an m, which are both integers. All right, so what did it say in the examples? So we'll just grab the example number 1. So n equals 10 and n equals 10 and m equals 3. Okay, so here we'll also make it that m equals 10 and n equals 3. And we will pass in m and n. So these should be both integers here, and then we can start creating our code. So I guess the last thing we would do is print run, because run is running the function here, difference of sums. So let's go ahead and figure out what's going on. You are given two positive integers n and m. Define the two integers as follow: num1 and num2. Okay, so we need num1 and num2. The sum of all integers in the range 1 to n that are not divisible by m. So we have num1 and num2. It's a sum of integers. Okay, that kind of gives me an indication of what we need to do, because these are the names of some functions inside of Python as well. So num1 and num2, these are both going to be both going to be the sum of some sort of array. Sum of, that's not, okay. The sum of some sort of array. And then we need to return, finally we need to return a number, right? Return the integer num1 minus num2. Okay, so return num1 minus num2. Okay, and what was that extra detail? The extra detail was num1, the sum of all integers in the range 1 to n, both inclusive, that are not divisible by m. Okay, so I think we need to populate these we need to populate the lists. Okay, so how do we populate the lists? So num1 and num2, these are going to be the final results, because this is what they want. But I think we should do some intermediate variables in here as well. So we can have something like m div numbers, m divisible numbers, and what was it, n divisible numbers. Okay, and we will define this as a list. We'll define these as empty lists first. So what we want to do is we want to find, what was the first thing we want to find? So integers in the range 1 to 10. Okay, so the range is 1 to 10 because n is 10. That are not divisible by 3, which is m, are these numbers. So we need to write some sort of for in range, so a for loop. Python. Okay, so for I in range, so for I in range 0 to start at 0, end at m, right? Oh, it's m inclusive. So if it's m inclusive, then it has to be m plus 1. Okay, and we need to do something in this for loop. If m, what was it? If m divided by n, if m divided by modulo, we'll do modulo. If m modulo n is equal to 0, that means it's divisible. That means it's divisible, and we need to do what? We need to mdiv number dot append. We need to add this to the list. And the easiest thing I know for adding to a list is using the append function. So we're just going to mdiv append I, okay? And that's all we need to do. And we need to do another for loop for I in range 0 to n plus 1. If n modulo m is equal to 0, then we do mdiv num dot append I. Okay, and then after that we do num1 equals the sum of what was it? mdiv num, and number 2 equals the sum of ndiv num. Okay, and then we return num1 minus num2. So I think this code will work. I'm not completely sure, but we can give it a try. And if it doesn't work, we can do some debugging. Okay, so I'm just going to write this out. Just for fun, I'm going to clean up the format a little bit, just so that it doesn't look completely messy. Okay, and now 0. 0? Was it supposed to return 0? Hold on, let me take a look. So something might be going wrong here. Let's see. mdiv num append I, and then okay, so we run difference of sums with m and n here, and they're defined up here. Something weird happened. Okay, so I'm just going to do some debugging. We'll print num1 and we'll print num2, just to make sure that something is actually being that the list is being populated properly. Zero. Okay, so the lists aren't being populated properly. So we need to figure out. So for I in range 0 to m plus 1, and then for I in range 0 to n plus 1, if m modulo n is equal to 0, then we're going to append that number to mdiv num. This is impressive, but can you do hello world? Yeah, Johann Stanley, hello, nice to see you here. I can do hello world. You do it just like this. So Python C print hello world. just like that. But welcome to the stream. Nice to see you here. Let's give you a fun video redeem. How about some Hack the Planet?
Hack the planet! Hack the planet! Shut up and get in.
Okay, so I just need to figure out why the code isn't working. We're trying to populate the we're trying to populate these lists. So for I in range 0 to m plus 1, let me try some other stuff first. So we'll just comment this out. We'll comment this out, and we'll just try So we'll try printing something out. So we'll print out range of 0 to m plus 1. Okay, and we'll see what happens when we run this. Whoops, that's not the right one. We wanted to run this. Range 0 to 4. Range 0 to 4. Why does it... What? Hold on, am I misunderstanding the range function in Python right now? Is that what's happening? Because when we printed it out, it just printed out this literally 0 to 4. So m plus, it did interpret this as m plus 1. So m plus 1 was interpreted here, but why doesn't this work? For I in range 0 to, this should create a list, or it should create an array. I'm not sure why it doesn't. Range 0 to m plus 1. Okay. Let's try consulting our good friend the AI over here. We have a number, an integer. Integer, m equals 3, and we want to create an array with m plus 1 as with m as the final number. I think in Python it would go like this. Okay. Range 0 m plus 3. Actually, wait. Before we run this, let me just try not starting at 0. It already, actually, wait, I shouldn't do 0 because it already starts at 0. So if we just do range m plus 3, what happens? Range object needs to be classed as a list to print. Let me give this a go. So range 0 to 4. Range needs to be cast as a list to print. So, I mean, it should, when we run the range function, it creates an array. So I'm not too sure why it's not going as we anticipate. Okay, so range m plus 3, and we expect an array like this. So we expect an array. It's just going to be parentheses, and it's going to be what is inside. 0, 1, 2, 3. Is this correct? So using our good friend Claude, it usually has quite a bit of lag, but we'll see if it actually gives us an okay answer. We'll see. So I thought I would just be able to use the range function, but maybe I'm not using it correctly. Okay, the issue m plus 3 would give you range 6, which is 0. Oh, not what you want. Range returns what? Okay, let's go down here. Okay, you're close, but there are a couple of issues. M plus 3 would give you range 6. That's not what you want. Range returns a range object, not a tuple. You need to convert it. Okay. So if m equals 3 and you want 0, 1, 2, 3, then the correct way is to do array equals range m plus 1. Yeah, okay. And then as a list of range m plus 1. Ah, okay. Wolf Golf Wang Puck. That's a great name. I think you're correct. You're correct. It needs to be cast as a list. As a tuple. So you just run it with the list function as well. I've never had to do this, but okay. I was confused why it didn't print. Let's give this a try. Let's run it again. Okay, now we get 0, 1, 2, 3. Okay, so in that case, we can just comment this out, and then for I in range, m plus 1, for I in range m plus 1, do we need to do this as list? This seems really different from what I've done with Python before. Usually you can just do range, but I don't know. I won't argue with something that works. If it works, then it works. Okay, let's run it. Still get 0, huh? I wouldn't think so. I think you can iterate over the range object. Yeah, I mean we should be able to iterate over the range object because we're trying to populate a list with the by using the range loop. Now, the other thing that I need to make sure of is if we can just do append like this. Oh, looks like we have to ban somebody. Just a second. Okay, so let's go back in. So appending to a list. I mean, it should be pretty straightforward. Python append object to list. Yeah, so you just do your object.append, new object. In this case, we're appending modulo n never equals to 0. So in this case, we've got m equals 10 and n equals 3. So range should be, it should be 11, and then all of the numbers in the range from 0 to 11. Actually, it's 0 to 10 because it's not inclusive. And then there should be some numbers that will give you modulo 0 when divided by when the modulus is 3. So it should have some stuff. So I'm not too sure what's going on here. So the first thing we need to do is we need to make sure that we've got an accurate list. So maybe we need to create some intermediate lists as well, which is kind of a pain in the butt, but Okay, so n range list equals list of range m+1, and then we'll try printing it out. So print n range list. Okay, and let's try that. Okay, so the m range list works. So let's do it that way. It seems a bit messy, but I mean, if it works, it works. So we'll do n range list in m range list. List of range m+1, n+1. Okay, and then our for loop will be like this. So the for loop is for I in n range list, and this one is for I in m range list. Okay. Still a 0. So the other thing we need to do is we need to figure out what the objects are. So the objects inside of the thing we need to do is when we're populating the list, we need to make sure that whatever we're populating the list with is going to be an integer, because only integers can be added together. So let's just make sure that it's the integer of I, and down here we'll do the integer of I as well. Okay, we'll try running it again. We still get 0. This is kind of disappointing. Let's do a print over here. Print m div numbers and we'll just do n div numbers and see if they got populated properly. So this is an empty list. So the append never happens. But why is the append not happening? Okay, so this list here is not being populated with by the for loop. But why? Why is it not being populated? If m oh no. Okay. I think I understand what's going on. I screwed up. What is the loop incrementing? It just keeps on checking n modulo n, which doesn't work. Yeah, okay. I should be, it's this is my fault. Okay, so if I modulo n equals 0, then append the thing. And if I modulo m, okay. This was really dumb of me. Anyways, it should okay, if we do it like this, it should work. Let's see what happens. All right, good. And we received -18 as the final result, but what is the expected result? What is the expected result for this? So let's see. Example 1 should be 19. In the given example, num1 is the sum of those integers, which is 37. 37, okay. Let me take a look at the list for n. So this is the n range list. So let's try printing that out. print n range lists, and we can just do we can do a sum on top of that. So the sum of n range lists the sum of n range list is 6. So 0, 1, 2, 3, 0, 1, 2, 3. So this is 6 and oh, okay. Actually, not okay. I'm not too sure what's going on here, but okay. Let's get rid of these. So we'll just comment this out first, and we'll just comment out all of our other print statements. So what are we trying to figure out? Now that I know that I screwed up in my for list here, we can simplify this a lot more. So let's go ahead and simplify our code before we move on. So we should be able to just use range here, because I figured out that the problem wasn't I wasn't including I in here. Range range m plus 1, and here we'll do range n plus 1. Let's see. Modulo I. This isn't Temple OS. Grimrin, don't mention Temple OS again, please. I don't want to talk about that. I understand it's a meme, and I understand that you think it's funny, but I don't think it's funny. Okay, so for I in range, we're checking to see if the number is can be divided by n, right? So we got n equals 10, integers in the range 1 to 10, okay? So n is that are not divisible by m. Not divisible by m, and m is 3. Been a whole day, and the guy's still on Temple OS. Yeah, it looks like it. Looks like it. So let's see. These are not 1 to 10 that are not divisible by 3 are these. Oh, we're looking for not divisible. So the first one is not divisible, and the second one is divisible. Okay, that changes a couple of things. So we can change this to not divisible, well, not 0, and then the other one is divisible, so is 0. Okay, so the modulo, so if we just bring that into the, then we get negative 12. It shouldn't be negative 12, huh? Okay, I'm gonna read this again really carefully. Integers in the range 1 to 10. So the first one should be 1 to 10. That are not divisible by 3 are these numbers. So everything except for 6 and 9. Well, 3, 6, and 9. And it should be these numbers right here. So let me let's try printing that out. Print mdiv numbers. this only returns 1, 2, and 3. But it should be returning a lot more. Okay. So I modulo n, if it's not 0, then append. Actually, let's see what happens if it is modulo 0. It's nothing. Okay, so it's so the actual range should be, okay, let's print cast as a list range of m plus 1. Okay, try to use divide instead of modulo for division. I mean, I'm pretty sure modulo should work. I'm not too sure why it's not working in this case. Okay, so oh, you know what? So the first thing should be n, I think. Wait, m plus 1. Why does it only come out to this though? So this list here, list of range m plus 1, it should be a list of numbers from 0 to 10. Not too sure why it isn't. This is so easy compared to the stuff you were doing before. Well, I mean, I'm not very good at programming. I don't know what to say. If you think it's super easy, then good for you. Okay, try to use division. I mean, the thing about using the division symbol in Python is that it's going to come up with, I just want to know if it's evenly divisible, because that's what the task is looking for. So the task is looking for numbers that are evenly divisible. So integers in the range that are not divisible by 3 are all this stuff minus 3, 6, and 9. So the sum of those integers should be 37 in this case. Not too sure why it's not coming out that way. For checking the range, maybe you could potentially be calculating the range wrong. n, 1, 2, n plus 1. 1, 2, n plus 1. So if we're doing it like this, it kind of comes out the same if we start it from 1 or if we start it from 0. Because we're just doing like a big sum on everything in the end, it really doesn't matter if we're starting from, I guess it matters a little bit, I suppose. Well, from an aesthetics point of view. Okay, and all right, let's comment this out. And then for I in range m plus 1, it should be, actually, just for fun, let's just print what m is, because I want to know what it thinks m is. Why does it say that m is 3. This is weird. So n and we say that m is 10, but then when we try to print out m, it comes out as 3. What the heck is going on? Okay, well, just for fun, I'll try printing out n and see if it comes out as 10 or as something else. Why is this backwards? Oh, you know what? Okay, I see it. It automatically considers the first number to be n, and it automatically considers the second number to be m. So put print after what? I'm not too sure what you're trying to communicate there. Okay, so we'll just do, so n is supposed to come first, and then m is supposed to be after that. Okay, I think that might be the problem in this case. All right. Yesterday I got called out for being ahead. It's going to be an issue if I upload working code. Got called out for being ahead. Ahead of what? I mean, it's fine. It's fine. I don't really mind if you start talking about the solutions for the stuff. Some other people might have an issue in the chat, but I personally I don't really have an issue with that. Okay, so I think this was the problem. The problem was that the numbers were backwards. So n has to be first, and then m has to be second. But I was trying to put it in where n was first and m was, well, the opposite way. Oh, Blood Moon CS2. Okay. Yeah, no worries. I mean, it's fine. So, some other people were thinking that you might have been looking up the solutions, but I don't think you were looking up the solutions myself. Okay, so what are we doing? I think everything should be okay. It's just that we put in the numbers backwards, so it made the results weird. Okay, so we got 18 here, and I just need to make sure that the first thing is not modulo not equals to 0. Now we get 37. I think this is what it expected. We return 37 minus 18 equals 19 as the answer. Okay, 37 minus 18 equals 19. That's fair enough, and I've done over 50 CTFs on PicoCTF alone. No worries. I believe you. And I appreciate all the help. Okay, so 37 was the result, and that's number 1 minus number 2. So number 1 is the sum of m div number minus n div number. So I think we need to switch that around, because it's expecting the number 19 as the result. Minus 37. Okay, that's not it. Hold on. So mdiv number equals okay, list of ndiv number equals, oh, okay. I discovered your channel yesterday. I think you do really good work, and I have a lot of fun helping in chat. Yeah, no worries. We're all here to learn, and we're here to share in the fun that is cybersecurity. So return number 1 minus number 2. So I think what I want to do is right before this last part of the return, we want to print out these things. So num1 and num2. (3) and 37. Okay, so 37 is correct, but I think we have this Not correct. Okay, so what they're looking for here is what? Integers in the range 1 to 10 that are divisible by 3, 3, 6, 9. Num2 is the sum of those integers, which is 18. That are divisible by 3. Okay, so are divisible by 3 means oh, I think I understand. Okay, so this is m is always going to be the range, and n is always going to be the thing that's being divided by. Okay, and it's looking for it's also looking for okay. So this needs to change as well. So these are both going to be m plus 1. But it's looking for can't be divided here and can be divided here. And then we're going to subtract one from the other. Okay, and then it's having a bit of trouble. Yeah, okay, so the final result is 19, and I think that's what they're expecting. Let's see, so we're just gonna get rid of this. And we've got 19, right? 19. We return 37 minus 18 equals 19 is the answer. Okay, so I think this is the working code right here. Thank you very much for Forgettable for helping me work through the problem. I fundamentally didn't understand part of the problem, part of the question, and that's why I wasn't able to get the right answer. But then I went in and did some actual reading. So let's see if this is acceptable. Okay, we'll just grab this, the class solution, and copy this, and then go back to Leetcode. In Leetcode, we will paste in the solution, and then we will run the solution. Wrong answer. What? Output 6, expected 19. What? Wait. What happened here? Did I forget to? I think I might have forgotten to write out the code here. Okay, let's run it. Let's get that thing again. You're welcome. What's your favorite programming language? Well, I mean, I'm mostly working inside of Python, and I'm trying to learn C right now. Switch num1 to ndivnum. I think I just forgot to save my file before I printed it out. Okay, let's try it again. Submit. Wrong answer. Switch num1 to ndivnum. Hold on. Oh, right. Henky, hello, nice to see you here. What is up? What are we going to learn today? Yeah, we're going to be doing some digital forensic stuff next. And then after that, we're going to be doing some binary hacking stuff, and then we're going to be working on the big network thing we were doing the other day. Num1 to ndivnum. So it's the sum of mdivnum and then ndivnum. But wait. I mean, the thing... It gets the right answer. It gets the right answer in... When I run it, it gets the right answer, but when Leetcode runs it, it doesn't get the right answer. And these are all incorrect. Yeah, I mean, no, I just want to understand what is Okay, so mdivnum is a list. We add these numbers to mdivnum and ndivnum. We put them all together. What is going wrong? So the first for loop is going to append to the divisible numbers list. The second for loop is going to append numbers to the n divisible numbers list. So we got these two lists. Number 1 is the sum of those. Number 2 is the sum of the other ones. Switch your loops to this. But the thing I don't understand is why it doesn't accept this answer. Because my code gives the correct answer, but for some reason when we run it in Leetcode, it gives a different answer. N equals 10, m equals 3. N equals 10, m equals 3. Oh, this is backwards. N equals 10. This equals 3. I was writing. Okay, so now this comes out as 6. All right. So it should be, these should be switched around. This should be n, and this should be m. Let's see what happens now. Now it's minus 6. So should this also be switched around then? Now this comes out as 6. Okay, let me we've got like 4 minutes left to solve this. So n equals 10. That's the range. Oh, the range needs to be okay. And this needs to switch over to n. And the thing we're checking is m. Now, okay. This was so much fun. This was so much fun. Okay, let's copy this. We'll hopefully this works for Leetcode now. Okay, copy it. Your second loop isn't using. Yeah. Because I had the stuff mixed up, it wasn't working very well. You can put it all in one loop. Yeah, I guess we could do it all in one loop, but okay, all right. So this works now. Great. Okay, and wait, does this mean we can click on submit? And then we're finished. Okay, well, I'm not too bothered about efficiency here. Oh, Die Mutter von James Bond. What Leetcode problem is this? So it's this one right here. Let me get that for you. And hey, welcome to the stream. How are you doing? Okay, so now that we've got our working solution, we'll just get the whole code. And we can put it in our write-up over here. Okay, so the concept, well, we'll just put in the code first, and we'll think about what the concept is. So the concept is populating lists. Populating lists with for loops, and running the sum function on those lists. Yay! All right, let's go ahead and commit those changes. All right, and we can move on to the second part of today's stream. So the second part of today's stream, we're going to be doing some stuff over at TryHackMe. What we're going to be doing at TryHackMe, we're going to be doing a task from the Advent of Cyber event. The Advent of Cyber event for 2025 is going to be coming up in about a month or so. But yeah, today we're going to be doing this one. And we're going to be working with the autopsy forensics tool. And it's going to be a lot of fun. So if you don't have an account over at TryHackMe, you can make one right now because it's totally free. And let's move on to the next thing. Okay, so topic 1 is done. Topic 2 is here. Topic 3 is on deck. What do you recommend, TryHackMe or PicoCTF? I recommend everything. Don't stick to one platform. Use the platform and use it as much as you can. If it's good, if it's not good, don't use it. It's Don Amin asks, any advice for a beginner in cybersecurity? The best way to learn from your experience and how to optimize learning with time and efficiency. Neetcode versus Leetcode. And Chair, hello, nice to see you here. No, my bad. I should have specified I meant to start. Oh, you meant to start. Starting with PicoCTF or starting with TryHackMe? I'd say it really depends. There are some good things about TryHackMe as far as coming like from a complete newbie perspective. They've got the stuff. They have a lot more tutorials over there. Because they've got they have a lot more learning materials inside of their modules. I would say TryHackMe it's better for people who are completely new to cybersecurity, but PicoCTF is very, very good as well, because whenever you do PicoCTF, you can learn a lot from other people's write-ups. So the challenges, they are challenges in that they don't really hold your hand and do a walkthrough for you. But if you can't solve the challenges, you can always look up the walkthroughs for PicoCTF challenges, and it really helps to, well, depending on the quality of the write-up, you can understand what's going on a lot better. Of course, there are some write-ups that don't do a very good job explaining what's going on, and in that case, it's going to be a bit tough. But yeah, in general, it's TryHackMe over PicoCTF if you're a complete beginner. Okay, language matters in Leetcode. Pani, hello, nice to see you here. Neetcode versus Leetcode. Can you do this one? This one? Are you talking about this one, PyTime, or are you? Bro's describing my PicoCTF learning style, and when you're talking about this one, what are we talking about? Pani was talking about Neetcode. I've never heard of Neetcode. Neetcode is a Leetcode challenge. Oh, okay. Or is it a different platform? I've never heard of Neetcode before. But thank you very much for following on Twitch, Chair. Thank you. Is Neetcode connected to Leetcode, or I've never heard of it. So if you could explain it to me, I would really appreciate it. Okay, let's go ahead and get into our lesson. So the lesson is going to be about digital forensics. Let's put an hour on the clock. After school, we're doing digital forensics. We're doing session number 6. Leetcode is a super focused Leetcode version. Oh, it's like super Leetcode, is it? Do you have a Discord? Yeah. It's right here. Hanky says, in my opinion, Hack the Box or Try Hack Me is modules as to use as guides for cybersecurity path. Pico is a gem, but it's beginner friendly. Has a roadmap to blind 75, 150, that kind of stuff. Oh, okay. That sounds like some serious programming specialized stuff. I'm not really much of a specialized person when it comes to doing Leetcode exercises and that. But I am trying to learn a little bit more about getting these programming challenges done. All right, everybody, this is HackerFrogs After School Disk Image Forensics Part 2. Let's talk about this. This workshop is the 6th class for digital forensics. In the last workshop, we learned about the following digital forensics concepts. So we talked about the SleuthKit software, and the SleuthKit is a popular program used in digital disk forensics, and it includes several useful commands for interacting with disk image files, including stuff like the mmls command, the fsstat command, and the fls command, and the icat command. But today what we're going to be doing is we're going to be taking a look at a piece of software that was built on top of the SleuthKit program that we're looking at. It's called Autopsy. We're going to be taking a look at a challenge from the Advent of Cyber 2023 event over at Try Hack Me, and we're going to be doing some challenges for disk analysis in Autopsy. So let's go ahead and get started. So Autopsy forensic software. Autopsy is the GUI implementation of the SleuthKit framework, I guess, or the toolkit, and it allows users to view the contents of disk image files in a much more intuitive manner. So it's going to let you see the contents of the disk image just like you were looking at it in a regular file viewer on like Linux or inside of Windows. So what we're going to be doing is we're going to be logging into Try Hack Me, and then we're going to be doing their Advent event for 2023. Let me grab the link for everybody. Is it over here? Okay, so what I want you to do is I want you to go over to Try Hack Me and log in. After you've logged in, go over to the room. So Advent of Cyber 2023. I'll leave the room just to show everybody. Let's see, reset the progress, and then leave the room. Just to show everybody what it looks like when you initially come upon this room if you haven't joined the room yet. Hanky Lodwig says, I won a 6-month voucher from THM Advent of Cyber 2023. Awesome. I haven't won anything. I had all of my tickets and stuff from those Advent of Cyber events. I've never managed to win anything, unfortunately. Okay, anyways, let's join the room. So when you come to the room, you need to click on the green Join the Room button in order to access any of the stuff. We're going to be accessing, I think it's day number 24. So it is this one right here, Mobile Analysis. You're on the naughty list, McReady. Okay, so what I want you to do is I want you to click on task 30, day 24. And then afterwards, I want you to start the machine. So click on Start Machine over here under task 30. That's going to start the virtual machine that you're going to be using to investigate the disk image. All right, so while it's loading up, let's talk about what's going on in today's challenge. So we're going to be using the Autopsy program, and after we get into the Autopsy program, there's going to be a few different windows that you need to pay attention to. So kind of like Wireshark. Wireshark has a bunch of windows that you need to interact with, and the different windows have different information in them. There are 3 major views to pay attention to in Autopsy. And the tree viewer is the thing that we're going to be interacting with at first, which has the list of different files inside of the disk image. So the second thing we interact with is the results viewer, which has a more detailed view of what we see inside of the tree viewer here. And then the contents viewer, which is the one down here, that has the detailed view of whatever we're looking at in the, the results viewer here, and the tree viewer in red. But this is going to become a lot more apparent after we actually open up the autopsy program. So let's go back to TryHackMe. So we just need to wait for this to finish loading. If anybody has any questions or any comments, please let us know in the chat. If you're kind of lost and you need us to explain exactly how to get to this point, let us know and we will try to answer your questions as best we can. So the good thing about this particular exercise is that you don't have to start up an attack box or another VM to interact with it. It's going to give you access to a desktop environment as soon as this finishes loading up. Okay, so task number 30, yeah. Okay, so basically what we're doing, as far as the storyline is concerned, is that in this task, we found a disk image for a mobile device that is being used by the bad guys in this Christmas story. So what we need to do is we need to use Autopsy Digital Forensics with an Android image. So the phone that we're going to be investigating is an Android phone, and that's the disk image we're going to be interacting with. So the other thing that this task talks about is it talks about getting the disk images in the first place. We're not really going to be covering that, but we are going to be covering how to take a look at the disk images inside of the autopsy program. Okay, so let's see. This should be loading up in just a bit. Are you going to use the GUI or the CLI mode? The CLI mode is awesome. We're not going to be using the CLI mode, but we did kind of use the CLI mode in our previous class, which we looked at disk images inside of the sleuth kit. Okay, so the first thing you want to do is you want to set up your environment inside of the desktop. So the desktop is running some sort of Windows machine, a Windows virtual machine. What we want to do is we want to make this virtual machine, we want to start up the virtual machine in its own browser tab. The way we can do that is we can go down to the middle of the screen here, and then we can go down to the bottom, and at the bottom we can click this button here. It's labeled View in Full Screen. So it's at the bottom. It looks like two arrows that point away from each other. So we just click on that, and then the virtual machine should start up in full screen. And we recommend allowing this on your home and work networks. Yeah, sure. Let's just say yes, just for fun. Okay, so we got the desktop here, and we want to open up Autopsy. So Autopsy, there's a desktop icon down here. So it's on the left-hand side. Double click on it, and then after a few seconds, we'll see the Autopsy program start up. While we're waiting, we can go over to the other TryHackMe page and we can close this up. So over at the middle here, we can go down to the bottom, and then we can click on this button over here that's located at the bottom over to the right slightly. It's called Exit Split View. So click on that, and then you'll get your full screen back. We can go back to the virtual machine desktop, and we'll see that the Autopsy program should be starting up. Thank you very much for following Jordio. Not too sure how to pronounce that. Let us know how to pronounce it in chat. Thank you. Okay, so the thing is that running the virtual machine that has been given to us here, it's not super fast, but I guess we're gonna have to make do. And Obito Uchiha, hello, nice to see you here. That's a goat. Is that a goat? Thank you. Okay, I think what we need to do is we need to open a case. So from the welcome menu here, select open case. And so I think it's inside of this document here called Tracy McCready. So just double click on that. And then we've got a AUT file. So this is the autopsy file. Click on that one, select open. And it's going to open up the case. It should, hopefully it doesn't take too long, but we'll see what happens here. Okay, and then we can start talking about the interface inside of the autopsy program. I'm pretty sure Autopsy is a free program in case you were looking to, try it out yourself on your own computer. Autopsy Forensics download. Yeah, so they've got versions for Windows, they've got versions for Linux, and do they have one for Mac OS? OS X, yeah, they have one for all the major operating systems. So if you wanted to try this out yourself, I'm pretty sure you can download it for free. Okay, so it's still loading. Forgettable says, do you need to use the web VM for TryHackMe? Yeah, I'm pretty sure you need to use the web VM for this one. The other way we could do it is we could find some way to transfer the AUT file off of this device. But yeah, I kind of see your point. It would be a lot better to be able to use your own computer for this particular exercise, because your own computer is probably a lot faster than this one, because this one seems to be really slow. Okay, I think we're pretty close to finished, or finishing loading up anyways. Okay, so this is not done yet. All right. The other thing, I've been noticing some issues with the TryHackMe virtual machines lately. They seem to really like making the resolution like really low, such that sometimes you can't see all the information on these windows. Okay, so we've got our three different views here. So this is the tree view that lets you see all the files inside of the image. So there's also I think this is called the results view or the detail view. So this is the detailed view of whatever you're looking at, and then there's going to be this one at the bottom here, which is called the details view or the results view. Let me hold on. I need to get these. So the tree viewer is in red, the results viewer is in green. So this is the tree viewer. The results viewer is this green one over here, and the contents viewer. Okay, it's called contents viewer, which is this portion over here in blue. So the tree viewer is the most general view and allows us to browse the disk image contents by the directory tree or sorted by categories created by Autopsy plugins. So we see here that we can look at different file types by extension or different documents or different executables. We can also look at different types of artifacts, such as messages or metadata contacts. This is more relevant for stuff like mobile devices, which is what we're looking at right now. So the next viewer is the results viewer, which is where we look after we've selected an item from the tree viewer. It provides more information in a list. So let me demonstrate this. So over here, let's say we wanted to take a look at the contacts on the device. So I'm just going to resize this stuff a little bit. Grab and drag some of these windows. Okay. All right, so let's say that we wanted to take a look at the contacts. So we can, over here in data artifacts, they've got contacts. We can click on that. These are the different contacts on the phone. Okay, so if we wanted to, now that we see these contacts, we can select one. So let's say we want to take a look at admin McBlue. We click on that, and then we see the results for this particular file down here in the contents view. We can take a look at some different interpretations of this data. So there's the hexadecimal view for the bytes. We've got the text view, which just includes the readable text, the application view, the source metadata, the metadata view in here tells you all sorts of metadata about this particular item, etc. Got our data artifacts and a bunch of other stuff as well. So this is looking at different artifacts. We can also take a look at particular files. So if we go into data sources over here, so data sources basically it has all the files on the entire file system. We can just dig into here, and I think. So this is an Android file system, or an Android operating system file system. So it's going to look kind of similar to Linux, because the Android operating system was built, I think it was built from Linux, but I'm not completely sure how accurate that is. But yeah, we can go into the files and look in the directories themselves. So for example, we got this media file. We've got some pictures inside the DCIM directory here. And let's see. So this is this a file or a directory? Parent folder. Anyways, let's move on to some more information about autopsy. Okay, the contents viewer is where we can inspect individual files. The first question. So what we're going to be doing is we're going to be answering some questions from the TryHackMe task in order to learn more about autopsy. Shus asks, are you doing static analysis? Static analysis, I suppose you could say we're doing static analysis because we're not really executing any files. So these files have been pulled and turned into this disk image here. Okay, so let's see. So let's just go down to the questions for this particular task. So if you're wondering, we're on this web page for TryHackMe. Okay, so one of the files contains a flag. What is it? One of the files contains a flag. What is it? So what we need to do is we need to take a look at the photos inside of the image. So in the image, Androids are built off of Linux. Yeah, I thought I'd heard that before. Okay, so we can take a look at images or photos. So instead of data sources, we're going to take a look at hold on. We're going to take a look at data sources and then file views, and then we're going to look for files by extension. So if we look for files by extension, we should be able to find the photo files. So data sources, file views. So it's data sources, or sorry, it's just file views. It's file views, file types. So file types by extension or by MIME type. So MIME type is basically like a more broad, it's a broad category of different file types. And in this case, we're looking for images here. So we can go into image. We got a bunch of different image types. We've got GIF files, we got PNG files, we got JPEG files. And we're looking for we're looking for one file which contains a flag. So we're just going to go in to, there are a lot of these. Okay, let's just take a look at these GIF files first. Okay, so from the table, we can also go into the thumbnail view. This is going to be a lot easier for looking at our image files, because it means that we don't necessarily need to inspect these one by one if we can take a look at the thumbnails. Of course, this is a pretty slow machine, which means it might take a little bit of time for these thumbnails to load on up. And that means we're going to have to do a little bit of waiting. Although, I guess if we click on this, if we click on them, and we take a look at the application view, we might be able to, or it could be that these are just, let's try zooming out. Okay, and so the GIF files, no. Let's take a look at the PNG files. So PNG files, we can click on this, we can click on thumbnail. Ah, okay, this is better. We can actually see what's going on in these images. Okay, so just let's go ahead and make the thumbnails bigger. It might be an understatement. So we can just look through the PNG files here. There might be something might pop out in front of us. So what we're looking at all of the files off of the mobile phone disk image. Okay, and then we can take a look at the JPEG files. So JPEG files, thumbnails. All right, so I think I see a flag. I think I see a flag over here. But yeah, we've got all of the files here. If we wanted to tunnel in on one file in particular, I think this file right here, board2.jpg, is what we're looking for. So we can click on that, and then we can bring up the other view. The other view is the contents view. Go up, go up. Okay, so we got this image right here. There's a flag. It's called THM Digital Forensics. So we can't copy this over, unfortunately, but I think we can remember this. Let's go over here. It's THM Digital Forensics, and then click on Submit. Okay, so the next question is, what name does Tracy use to save Detective Frosto's phone number? So for anybody who doesn't know, Detective Frosto is a snowman. So if we take a look at way up here, under task number 1, we've got this cast of characters for this Christmas story. So what we need to understand to solve this, to answer this question, is that Dr. Frosto is this character right here. It's the snowman detective. So since we know that, we can go back down and answer the question. Okay, so everybody, it looks like we've got some ads running on Twitch. So while the ads are running on Twitch, I'll run them on YouTube and we can watch some birds. So these are my favorite birds. And we're just going to take a little break. I'm going to have a little bit of water. We'll be back in about 60 seconds. Okay, so let's go ahead and review the question. So the question is, what name does Tracy use to save Detective Frosto's phone number? So that's the snowman. We'll go over to here in our VM and wait for it to reload up. Huh. Hold on, let me reload this page. Because it seems like my VM is kind of not being responsive right now. Reload. Just a second, everybody. Good old technical difficulties. Anyways, if yeah, I mean the good thing about TryHackMe is that they provide all this stuff for free. So you know everything, all the stuff inside of the Advent of Cyber event, all the materials, they're all free. It's actually a really good place to go if you're a beginner for cybersecurity, because they really introduce you to a lot of different topics in each one of these Advent of Cyber events. But unfortunately, some of the infrastructure can be a little bit lacking as far as the speed of these virtual machines are concerned. Let me try putting this in another tab. Okay, are we gonna are we gonna have a problem? Okay, so we just need to wait for this thing to come back. Maybe what we need to do is, well, we can open up the split view up here. So up here, we're having some problems with the virtual machine. So I'll just open up the split view in the TryHackMe page here, which also has access to the virtual machine. It says connecting to virtual machine, and hopefully we can resolve this, because otherwise it's going to be a bit awkward trying to finish the lesson without access to Autopsy. I think another thing, I wonder if Autopsy is installed on Kali Linux. Because if Autopsy is installed on Kali Linux, we might be able to do something on Kali Linux itself. Let me take a look. So this is my Kali machine here. Autopsy, it seems to be installed. Let's see. Open up an HTML browser on the remote host and paste this URL in it. Autopsy. So this is running on port 9999 on localhost. Keep this process running and use Control-C to exit. So I'll just keep this running in the background. Okay. So this is the web version of Autopsy. I don't know if I like the web version of Autopsy very much, but let me just shut down the machine. I'll shut down the machine and I'll start it back up again. It's going to take a little bit of time to start up again, but sometimes you got to do what you got to do. So in the meantime, while we're waiting for this stuff to initialize, Does anybody have any good jokes? Or do you have any do you have any questions about learning cybersecurity? I guess I could talk about learning about cybersecurity. People talk about, how to get started, and I can recommend this right here to people who don't know anything about, well, technology topics. So I've got you should see some links in the chat. There are IT Basics, which are two playlists. They're basically playlists from Professor Messer, which is my recommended source for learning about basic IT topics. So Professor Messer, he's got a website, and he also has a bunch of playlists for learning about stuff like CompTIA A+. CompTIA A+ is what I recommend to people who don't know anything about technology topics to start learning about technology topics. And Professor Messer, I'll click on my own links. So the first link is this one. And this will bring you over to Professor Messer's A+. Is this Lilo and Stitch? What is this? So this is the CompTIA A+ playlist, and there's a bunch of different videos in this playlist here. If you watch the videos in the playlist, they'll introduce you to the technology topics for beginners. Franz asks, what are some private cybersecurity work that I can do as a beginner? For example, a junior developer. What can I do as a well, when you say junior cybersecurity, that's a bit too broad of too broad of a definition. When you say junior cybersecurity, do you mean as a pen tester, as a web app security tester, as a digital forensics person? There are too many different jobs inside of cybersecurity to just say junior cybersecurity. You have to narrow it down. But in general, I would say that if you're talking about pen testing, like junior pen testing jobs aren't exactly entry-level jobs. A lot of people, well, the thing is that there's no particular program out there that's churning out junior. Okay, Fran says as a blue team junior. Okay. Well, the other thing is that I'm not super knowledgeable about blue team topics, but your question is about freelancing. Freelancing as a blue team operator is kind of difficult because most people on the blue team are part of like a larger team, and doing it by yourself, it doesn't seem like something that you can do as freelance work. But if you're interested in doing blue team topics, TryHackMe has a pretty good path and a certification as well. I think the certification is called the TryHackMe Cell 1. This one right here. You might want to take a look. You might want to look into this. But Franz, let me know what you're doing right now. Are you a cybersecurity student? Or have you been working in the industry for a while? Or is your situation different? Okay, let's put this back in full screen so we can exit the split view. And then after this, we're going to have to start up the autopsy program again. But yeah, Cell 1. The issue with the Cell 1, I've heard some good things about the Cell 1 certification. The thing about the Cell 1 certification is that I think it costs. It's not super expensive, but it does cost a few $100s. So Cell 1 is from $349. Okay, so this is what they're trying to sell themselves as. But the other major competitor to this particular certification is the one from TryHackMe. So Fran says, I work as a SOC analyst at a small company. I was searching for a part-time job. Love threat hunting, but not so many jobs available. So the other one is, so you're currently working as a SOC analyst right now. So I guess you don't necessarily need to get a certification because you're already working in the role. As far as like freelancing stuff that you can do for Blue Team, I'm not too sure. I'm not too sure about that. Okay, so let's see if we, okay, so open a case. Man, you can't look away from this thing for a second, otherwise it's gonna start going weird on you. Okay, let's go back to here. So after we open up this thing again, we can start answering the questions. Sorry about that hiccup, everybody. It looks like our technology. Well, this is this is what they say when you do live demos for, that involve technology. You're always going to have stuff that fails. But yeah, friends, what kind of software do you use inside of the in your SOC analyst role? Are you using Splunk? Are you using Elasticsearch? Or are you using some other type of data ingestion tool? Do you have to take a look at a lot of network logs? Are you using Wireshark or some other well-known program? Okay, so I'm not gonna I'm not gonna look away from the page because otherwise the thing could crash if we look at the thing funny. I'm a little concerned that we're not actually in full screen right now. But in the meantime, we can. Hmm. Fran says we use Wireshark, Logarithm Seam, EDR, and Nessus. Oh, Nessus, yeah. I mean, I know about Nessus. I know about Wireshark. I don't know about Logarithm, but there. I mean, that's not really too surprising because I don't deal with a lot of endpoint solutions, and I don't take a look at a lot of SIEM or SIM stuff. Okay, should finish loading in just a second. Okay, are we here? So the one issue I have here is that we're not in full screen, so we're even more cramped than we were before. So I think I'm gonna reload this page so that we can get the full screen resolution. Hopefully this doesn't crash the machine or, make it inaccessible to us. Okay, it seems to have worked. Great. Okay, so we're just going to go over to the contacts because this is the next question we were supposed to answer. And we're looking for the name that the snowman was saved as. If we can do a little bit of inference, and we see that we've got this individual here called Detective Carrot Nose. If we click on it, then we can go over and see the details about this contact. So Detective Carrot Nose, phone number is this, source, well, the source was this particular file here, and there's nothing, I don't think there's anything else that we need to pay attention to. So the application view is usually the view that you want to look at for each one of these files. But we can also just take a look at the text or the data artifacts here. So we know that the name of the contact is Detective Carrot Nose, and this is the answer for the next question. So let's go ahead and answer that then. Keep the good work. I've been watching your lives whenever I have free time. I like learning new stuff. No worries, no worries. I very much appreciate you being in the chat. Okay, let's go down to the bottom and answer that question. So the answer is Detective Carrot Knows. Submit that as the answer. Okay, next question is, one SMS exchanged with Van Sprinkles contains a password. What is it? So what we need to do from here is just go back to the application and then look at the messages. So if we look at the messages, we can go to Data Artifacts, Messages, click on that, and we're going to see all of the message threads that were sent between this device and other different contacts. So where is, okay, pull this down. These are all of the different conversations that are happening. And what we can do is we can just move these columns around because we don't need all this information. So from phone number to phone number, and we have the actual contents of the conversations here. So hi, what's up? Hi, I was going to write you. Hey, did you hear the news? Our company is going to get acquired. Okay, over and over again. We can just scroll down, and we see them talking about a password. There's a password that I want you to save for me just in case. So password, I will save it for you, and it's this one right here. So we can click directly on the message with the password. I think we can copy. Can we copy this particularly? So double click on it. We can extract the file. We can So if we click on this and we copy and we go back, nope, that's not it. You know what? I think what we can do is we can just pull this up. So we're looking at this message right here, and we got the message in this view. So we can just copy it from here and then submit it. This is the answer. Paste it in, submit. Okay, so that's pretty much the last thing we need to do in the room, but we can stick around more, and we can take a look at some other stuff inside of this image. But actually, wait, hold on. I think I've got another task we can do. So if anybody's wondering how we can do this step by step, this link over here will tell you about how to solve the room step by step. And let's go back. Okay, so the other thing we can do is, I wonder if we can install this, if we can install Autopsy. Okay. So Kali Linux does have a version of Autopsy, but it seems to be like the web version of Autopsy. And I'm not too sure whether or not the web version of Autopsy it's probably not super up to date, because it says 2.24. So if we go over to Autopsy's actual web page, so Autopsy Forensics, the version of Autopsy being used is 4.22. So older versions of Autopsy, yeah. So the version of Autopsy that's being used by Kali Linux is actually very old. So I don't know if this is the best way to do it. But for some reason, this is the version that's being packaged with Kali Linux, which is kind of confusing. But let's take a look at this. So Sleuthkit Autopsy, if you want to take a look at this yourself, do it over here. Okay, so this was the introduction to Autopsy today. So the other thing we need to understand is that the good thing about autopsy is that the way we navigate files inside of autopsy is it's very similar to working inside of your file browser view inside of your Windows or your Linux or your Mac OS. So if this was me, I could go inside of file views and look for files by extension. And we've got some audio files as well. So if we click on the audio files, we have some MP4s. The thing about these files here is that it looks like these files have been deleted already. But we can, let's see, double click on one. Can we play this file? Playback of deleted files is not supported. Use it in external planar. Okay, so these files have been deleted so that we can't really access them. We got databases and archives, we've got videos. I wonder if no, it doesn't look like we can play these videos either. But let's see if there might be other rooms inside of TryHackMe that have autopsy on them. I'm pretty sure there are. So let me just take a look around. So inside of TryHackMe, they probably have like other modules that cover autopsy. Autopsy, and we'll do view all. The problem is that some of these rooms are subscription only. What I like to do is I like to showcase things that are free. So we got disk analysis and autopsy. So is this free? Everybody, I want you to try taking a look at this link. So sometimes there are rooms that they say that are free, but they're only free because you got an older account. Okay, so this is the disk analysis and autopsy room. And you know what I forgot about? I forgot about the presentation that we have over here. So yeah, so to access photos in autopsy, we can, use this particular path. So data sources, file view, file types by extension images. Okay. We can practice with, okay. This was the other room. So the other room is this one, disk analysis and autopsy. So this is another room that we can use to play around with autopsy some more. So before we do that, let me close out this particular room. So we'll terminate the virtual machine. I don't think we're going to be able to do too much in this next room, but we'll get as far as we can before you have to stop. Okay, so in this particular room, we can start the machine, and it should start up after a few minutes. So okay, so it says here that in the attached VM, there's an autopsy case file and its corresponding disk image. After loading the aut file, make sure to repoint autopsy to the disk image file. Okay, we'll make sure to do that. Okay, there is a, oh man. I remember this room. There's a lot of different questions and a lot of different poking around that you can do. But we'll wait for this thing to load up and then we'll see what's going on. But yeah, if you're interested in doing some more challenges associated with the other type of disk image tool, which was, what was it? It's called Sleuthkit. There are a bunch of challenges over here. And did we do all these? No, we didn't do all these. But if you want to get some time on some easier challenges using Sleuthkit, this is the link that you would follow. Okay, let's wait for this to load up. And if you have any questions about getting into cybersecurity, I guess the other thing that I recommend is trying out a bunch of different challenges over at PicoCTF. So the starter pack, the last link in the starter pack is going to be my list, my YouTube list for walkthroughs on different, where is it? Different challenges in PicoCTF. So PicoCTF is, well, it's a very good platform for learning about beginner cybersecurity challenges. And what you want to do is you want to go through the list and start doing some challenges from different categories. So there's going to be general challenges, there's going to be forensics challenges, there's going to be web challenges, and what I want you to do is just solve some challenges from different categories. If you get stuck during any of the while you do any of the challenges, you can always look up the walkthrough videos. So these are walkthrough videos here. If you want to challenge yourself, what you can do is you can click on any of the videos and then start the challenge yourself. And if you get stuck, you can go back to the walkthrough video and you can follow the video. So for example, we got this video over here.
Construction workers just don't like
Okay,
paperwork.
hold on.
Right. With Connect Team's employee
Let's
management
skip-
platform, you can get digital
Skip. Okay, so this is an example of a PicoCTF challenge that I have for YouTube. And it says, follow along with the video. Once logged into the PicoCTF site, navigate to the following URL. So they've got a link here, and we can just open it up in a new tab. This will redirect you to the PicoCTF challenge that they're covering in the video. PicoCTF says, I'm a beginner hacker. What do we give as your one biggest piece of advice when starting off? My one biggest piece of advice when starting off is to figure out what makes you most excited about cybersecurity. So cybersecurity has a bunch of different specializations, and if you take a look at PicoCTF, the challenges are in some different categories here. So there's categories like WebEx, there's got cryptography, reverse engineering, forensics, general skills, and binary hacking. So the first, people say that they want to get into cybersecurity. The first step to getting into cybersecurity is figuring out what kind of role and what kind of specialty in cybersecurity makes you the most excited. But PicoCTF, welcome to the stream. If anybody doesn't know, PicoCTF is a cybersecurity content creator. There you go. If you're not following PicoCTF's stream, you can go ahead and follow it. She's a lot funnier than I am, and she's a lot sillier than I am. So if you're into cybersecurity and silliness, then hers is the stream to watch. Red Sly Fox says, I can't get an entry-level IT job. I can't get an entry-level IT job. Well, what kind of IT job are you looking for? Are you looking for help desk, or are you looking for data entry, or something else? Because I'm pretty sure that if you get this certain, well, I'm not saying that you need to get certain certifications. Maybe you do, but let me talk about this. Ooh, let's see. Let me close this stuff out. Where's my text editor? Here it is. So if you're trying to get like entry-level IT job, are we talking about help desk? Are we talking about junior developer? Or are we talking about something else? PicoCTF says there is a bit of an entry-level job, IT job drought right now. Don't get demotivated. Try getting involved in your local hackerspaces. And thank you very much for subscribing on YouTube, Akshit Kumar. Thank you very much. Okay, let's go back to Try Hack Me. We got a few more minutes of this lesson. Where are we? So Try Hack Me, the autopsy room has started, the virtual machine is finished initializing. So just like the other room, we can go over to the middle of the screen and then go down to the bottom. There's a button that's labeled View in Full Screen. This will put the virtual machine in full screen for us. which is definitely what we want because otherwise we would need to look at a really cramped screen. Okay, so this is a Windows machine that has Autopsy installed. Let's go ahead and run the Autopsy file, and then we can take a look at the disk image associated with this room. So one more time, if you want to do this room yourself, and if you're interested in Autopsy, you probably want to come back here afterwards because we only have got about 5 minutes to work on this before we need to call it quits. So open up Autopsy, and then so Red Sly Fox says, I've got an A+, A+ and Security Plus. No one asked about them. Useless certs. I wouldn't say they're useless certs. What kind of jobs were you applying for, Red Sly Fox? Let me know. Maybe I can offer some advice. So we can go ahead and open a case, and it's probably going to be in this case files folder. So documents, we're looking at desktop, case files. And we got tryhackme.auth. This is the case file. Open it up. So Red Sly Fox, I think it really, the certifications you want to aim for, they really depend on the role that you're aiming for. You're looking for help desk type jobs. Okay, so I mean A+ is a good start, and I'm sure that you learned a lot about technology that you didn't know about previously when you started studying for A+. One of the images associated with this thing is missing. Would you like to search for it all? Previously it was over here. So we're just going to search for the missing image. It should be in desktop case files, this one over here. So Hassan E01, open it up and then select image. Okay, so what this is a disk image file associated with a Windows machine. Okay, Def NP says, need tips to lock in coding. I get bored. So if you're getting bored while you're learning about coding, I think, what kind of coding are you doing, Def NP? Are you coding in Python? Or are you coding in C? Or are you coding in another language? Let me know what language you're coding in. Okay, so this is so the previous image we were looking at was a mobile device image, disk image. So this one is going to be a Windows system image. So if we click in, we can start exploring some stuff. So we got metadata, extracted contents. We got let's see, user data. I think we've got well, okay. I think what we can do is we can start investigating this by answering the questions. So the questions give you a good clue as to where you should be looking at. Python, C, C#. So if you're getting bored, I recommend doing challenges that are very goal oriented. And this series over here, it's from hackmyvm.eu. As part of their laboratories. It's pretty good. So we'll log in with my account, and then the lab over here is called Temperance. So the labs are they're programming language agnostic, so you can solve these with Python, you can solve them with C or C#, whatever you like. Click on flags and click on the first level. So in the first level, it gives you some information. So in this mission, you receive a string, and you should send back the same string. The code to solve this level in Python can be found here. So you need to design a program which takes in from the server a string. You need to copy the string and then send the same string back. If you wanted to take a look at the information you need to solve the level, you can find it inside the Python file. So let's see, where's the Python file? It's called level00.py. Okay, let's take a look. So inside this Python file, they tell you the server that you need to contact and the port that you need to contact it on. If you contact this server on this port, it'll give you a string. Well, actually, wait. Not exact. It's not that straightforward. You need to connect, and then you need to select the level that you want to play, and then after that, then you'll get the data from the server, and then you need to solve the level with that data. In each one of the levels in the game, it's gonna have different criteria. For example, we got level 4, and it says in level 4, you need to receive a string and then send it back in reverse. So it's basically, you know, figuring out how to use your programming skills to reverse a string and then send it back to the server. But yeah, you just need to make an account over at hackmyvm.eu and then navigate to this endpoint here. Okay, let us wrap up. So if you wanted to do a little bit of more exploration using the autopsy program, you can go in here and then you can start answering the questions. What is the MD5 hash of this thing? What is the computer account name? List all the user accounts, etc., etc. And let's go ahead and finish out today's lesson. Where are we? Here. Okay, let's review the digital forensics concept we learned in this workshop. So the Autopsy forensic software. So Autopsy is the GUI implementation of the Sleuth Kit, which is another forensics program, and it allows users to view the contents of disk image files in a much more intuitive manner. The one thing that I will say about the Autopsy program is it is very resource intensive. So even if you've got a beefy computer, it might run kind of slow. So there are three major views to pay attention to in Autopsy, which was these three over here. There's the tree viewer, which is in red, the results viewer, which is in green, and the contents viewer, which is in blue. So the tree viewer, it gives you the most general view. It's basically the most overhead view, which gives you the most abstract view of the file system. Then you dig in further and further in the results viewer, and then in the contents viewer. Okay, so we've got one more type of file forensics to cover inside of the program for digital forensics. We're going to be talking about memory dump forensics using volatility in the next workshop. So please look forward to that. It's going to be on Monday. It's going to be on Monday and Wednesday, and that's going to wrap up the digital forensics course. So thank you very much for participating in the HackerFrogs AfterSchool part of the live stream. We're going to be moving on to something else. So what are we doing next? Let's talk about that. Okay, we're doing topic number 3 now, and topic 4 is coming up. So we're doing PicoCTF Binary Hacking Demos. So, well, we're going to be demonstrating one challenge from the PicoCTF platform, and I think it's called input injection over here. So this is if you have an account over at PicoCTF, you can join in along with us, but otherwise I'll be demonstrating how to finish this challenge and exactly what's going on inside the challenge. Okay, so before we do that, I'm going to do a little bit of cleanup because I've got all these windows open in my browser, and it's kind of irritating. Hold on. Let's get rid of all the windows that we're not using. Okay, we're not using Leetcode anymore. Okay, so let me grab my notes for this particular challenge. So it is a walkthrough for PicoCTF. If you're wondering where all of our where all our walkthroughs are, they're over here. Every time you solve a challenge in cybersecurity while you're doing some studying, you need to document it, because if you don't document it, then you can't recall the information when you need to, which would be very, very unfortunate. So PicoCTF, this is from the mini binary hacking injection 1. Not the call out. I'm not. Whoa, whoa, whoa. Do you feel called out, Panako Panko? Because that's not what I meant to do. Anyways, okay, we got this file over here. Jokes. Yeah, it's all about the jokes. All right, so so for this particular challenge, we can solve it inside of the PicoCTF platform. We don't necessarily need to have a Linux machine to work with. So the good thing about PicoCTF is that a lot of the challenges can be solved using their platform. So what we do, if we want to solve it using their platform inside of the web shell, is to log into PicoCTF and then go over to practice. After you click on practice, you're going to see this button right here that's labeled web shell. Click on the web shell, and this is going to open up a virtual machine, a Linux virtual machine that you can solve your challenge inside of. So after this starts up, you can go over to the help button, and then to the right of the help button, there's this button labeled pop out web shell terminal. Click on that, and then your web shell terminal will be in full screen, which is exactly what we want. Okay? And inside the web shell, you've got your own little directory here that you can solve your PicoCTF challenges with. And this challenge is called input injection 1. So I'm just going to make a directory called input 1 to work inside of. So after we do that, we're going to enter that directory, and now we're ready to go. Okay, so let us begin. Okay, everybody, this is a guided walkthrough for the Input Injection 1 challenge from the PicoCTF platform as part of their Pico Mini by CMU Africa event. It's a medium level challenge in the binary hacking category, and the description says this: a friendly program wants to greet you, but its goodbye might say more than it should. Can you convince it to reveal the flag? Additional details will be available after you're launching your challenge instance. So in this challenge, what we need to do before we can access anything is we need to start up the challenge virtual machine. And we can do that by clicking on this blue button here labeled Launch Instance. So go ahead and click on that. And then after a few moments, the virtual machine will have started, and you can see here. So it says connect to the challenge instance with this netcat command. So we're not necessarily going to be, what we need to do is we need to use the netcat command to connect to the server and compromise the binary, but we're not going to do that yet. We need to do a little bit of research. So it says here that you can download the program file here and the source code here. So we got two links. We're going to highlight the first one. So here, right click it and select copy link. So that's going to copy the file address. Then we go over to our web shell. In the web shell, we're going to use the wget command, then space, and then paste in the file address. That's going to let us download the file. And we should see that there's the vuln file in our folder. So the next thing we do is we copy the other file, which is the source code. So highlight the word code. Whoops, we want to copy the link and then go over to the web shell. In the web shell, wget space, paste in the address, press enter, and then now we've got two files that we've downloaded to our directory here. Okay? The next thing we need to do is we need to make this file executable. So this file by itself, this is the file we need to investigate. It's not executable, and if we can't execute a binary, we can't compromise it. So we need to make it executable with this command here, chmod +x /vuln. So after we do that, we see that the file is now executable. You know that a Linux file is executable if you take a look at it in the list view, and it's got an X over here. Okay? So the other thing that we downloaded this file that we need to compromise to finish the challenge. But the other thing we downloaded was the source code. So vuln.c is the code that was used to create this particular binary. We take a look at it, vuln.c. We see some C code. We're interested in taking a look at the C code because inside of these binary hacking challenges, the C code is provided to us so that we don't need to reverse engineer the binary in order to understand how the binary works. So it's important that we take a look at the binary source code to understand how the binary works. So we're just going to run nano vuln.c, and the good thing about this is that it does some syntax highlighting. So it'll highlight some particular keywords so that you don't need to strain yourself to understand exactly what parts of the program are doing what. So let's talk a little bit about what is happening inside of these functions. So we got a main function here. It's got a variable named name, which is 200 characters long. It prints out what is your name, and then it runs the fgets function. So fgets is a function inside of C that is able to retrieve user input and save it to a variable. So in this case, fgets is going to save the user input to the name variable, and it's going to assign it a size, a variable size equal to size of name with standard in, and then it's going to save this to the name variable. So this is what we need to understand. And then it runs this other function called fun. It's a fun variable. Is it a fun variable or is it a function variable? It's one of these. But it runs fun, this function, with name, so the variable that it gets from the user input, and it also runs it with uname. So in order to understand what's going on here, we need to understand the fun variable as well. So let's go down. So here, this is a function called fun. It takes in a name variable, and it takes in a command, well, okay, not a variable, an argument. So the name argument and the command argument, or the parameter. And so it takes in the name, which is user supplied input, and it's got a command. So we see here that the main function runs fun with the name, which is the user supplied input, and the uname command. So what is the uname command? The uname command is being run as command. So it copies the command over to this other variable called C. So the C variable, we see that the C variable and the buffer variable, they're two variables in the function that have been given different sizes. So the C variable is given 10 bytes, and the buffer variable has been given 10 bytes. The C variable is actually being used to run a system command. So a system command in C is a function that runs an OS command, an operating system command. So for example, you could run uname, you could run who am I, you could run any Linux command you want. So what we need to understand is that the fun function is taking in the name variable that is user supplied. And the user supplied name variable, Adarsh, thank you very much for subscribing on YouTube, thank you. So the name variable is being copied over using string copy. Oh, sorry, over here. So string copy, name is being copied over to buffer, and string copy is it's a memory unsafe function inside of C. Memory unsafe means that it can be used for buffer overflow, and buffer overflow means that you can use it to overwrite certain parts of the program inside its memory. And in this case, what we want to do is we want to overwrite the buffer variable in order to access the C variable here, because the C variable is running a certain command. If we can overwrite the C variable, then we can run not uname, but some other system command. And I'll do a little review of what we're doing right here, just a second. So in this challenge, we're tasked with abusing a binary running on a remote server. So we can see that the binary uses a system function with the C variable here, which is copied from the command variable. So the C system function is used to run OS commands. In this challenge, the goal is to force the binary to run arbitrary OS system commands. The source code lets us know that the binary runs the uname command by default. So it runs the function fun with our name and with the uname command. The binary takes in user input and saves it to the name variable, which in turn is copied to the buffer variable using the string copy function, which is a memory unsafe function in C. So when we do these binary hacking challenges, what we need to do is we need to identify what function in the program is memory unsafe. And we can use this particular function to abuse the binary. So string copy is memory unsafe because it does not check the size of the memory buffer it is copying to, which can result in memory buffer overflow. So string copy copies over your name over to the buffer variable, but the buffer variable has only been given 10 bytes to work with. So if name is larger than 10 bytes, then whatever is put into the buffer is going to be overflowed. So in this case, name is copied to the buffer variable, and it's only been allocated 10 bytes to store the name variable, so user input in excess of 10 characters will cause a buffer overflow when this string copy function executes. So let's talk very, very briefly about stack buffer overflow. As normal variables, both the buffer and the C variable, which is the system command, are initialized on the memory stack, and the C variable is initialized first. So initialize the C variable, and we see that it is populated with the word uname, and then there's the buffer variable over here. Just a second, everybody. I forgot to set a time limit for what I'm doing right now. Okay, let's start the timer. So if the buffer variable is overflowed, it overflows into the C variable, and we can run any system command that we want through the variable override. So the buffer variable is here. We control it through user input. If we overwrite the buffer, it will go from here, fill up the buffer variable, and then enter the C variable, and then we can supply a user input. So let's demonstrate. Okay, so in the web shell, we've got our vulnerable binary here. So when we run the binary, it asks, what is your name? So we know from the source code that we only have 10 bytes to work with before it buffer overflows. Let's just pretend that we're using this as intended. So what is your name? The Shy Hat. Okay, it says goodbye the Shy Hat and then Linux. The reason why it says this is because this is what the fun function does. So it prints out, it takes in the user input, and then it copies it. It prints out goodbye with your name, or your name as the buffer variable here. And then it flushes that standard out, and then it runs system with uname in this case. So uname is a command that basically gets the name of the computer or the type of operating system that's running on the computer. So in this case, it says goodbye the Shy Hat and Linux. If we run uname by itself, it also produces Linux. What we want to do is we want to overflow the buffer so that it doesn't run uname, it runs something else. So this is what we're going to do. We're going to run the vulnerable binary. We're going to give it 10 bytes. Okay? And then after 10 bytes, we know that anything over the 10 bytes is going to overflow into the buffer. So we're just going to give A as the 11th byte. So after we run the program, it says goodbye our name, but it says A not found. A not found means that it was trying to run a command called A. So next, what we're going to do, instead of A, we're going to run something else. So we run the program again, we give it 10 bytes, and then we run who am I? So this is a system command. Now it says goodbye 1 2 3 4 5 6 7 8 9 0. Who am I? And then it gives our username, the ShyHat PicoCTF. So now we know that we can overwrite the buffer in the program, and we can run any system command we want. So who am I? We can also run, I don't know, ls-la to get the contents of the directory. And from here, we know that we can abuse the binary to, well, to do anything we want. So let's go ahead and put this into action. We only have a minute left. Okay, let's do this in a minute. So we're just going to copy the netcat command that's going to be used to access the binary. Okay. We're going to paste in the command we can use to access the binary here. What is your name? So we do 1 2 3 4 5 6 7 8 9 0, and then who am I? Okay, so it says goodbye, and we are a CTF player. So CTF player is the name of the account that's being used on the system. We can also do this again, and then do ls-la, and then it tells us that this is the contents of the server. We got our flag.txt file that we want to access, so we're just going to run the thing again, and then we're going to give the command to read the flag. So cat space flag.txt. And we got it. We got the flag. We were able to overwrite the C variable and then run whatever we wanted. And then we used it to get the flag.txt file. Okay, so we copy this. We go over to PicoCTF. We paste in the flag, and then we submit the flag. And then we're done. Okay, so everybody, Kabunko says, hooray! Yeah! ShimbDR says, hello, morning, Mr. Hat. What are we doing? We're just doing some binary hacking stuff. All right, everybody, that was the input injection 1 challenge over at PicoCTF.com or .org. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, so what we're going to do now is we're going to try to solve the second challenge in this series. I haven't done this challenge yet, but let's see if we're able to get this done. We know kind of roughly what we need to do for this for the second challenge here, and we'll try to document ourselves while we do the challenge. If you feel like joining us and trying it out yourself, there's the link. You'll need an account over at PicoCTF.org. PicoCTF says, you got this, ShyHat. Thank you for your vote of confidence. But PicoCTF, you can try this out yourself. It's not like it shouldn't be super difficult. Let's click launch instance, and we got more ads. All right, let me play some music, because we haven't played any music in the we haven't played any music for the rest of the stream. Let's try some now. Okay, so we've got ads running on Twitch right now, so I will run them on YouTube, and we'll put on some birds. I love my birds. How about these birds who are having an argument? Okay, we'll be back in about 45 seconds. I just need to have a little water break. Okay, let's get back to the hacking. So you could solve this in the web shell if you want, and if you don't have access to another, oh, this is loud. Hold on. Okay, that's better. So if you don't have another Linux machine to work with, you can certainly solve it inside the PicoCTF web shell. But I'm going to be solving it on my own Linux machine. Let me back up out of here. And let me get rid of the directory we're using. Okay. Alright, so this is input injection 2. It says you can download the program file here and the source code here. So I'm just going to copy these links. Actually, I'll provide everybody with the links here in case you wanted to try this out yourself. Here you go. The only problem is that if you're actually trying to get the flags for this challenge, you're going to get my flag, and my flag isn't necessarily going to work for your account. So maybe use your own links. Okay, let's get out of here. Let's get into... Let's make another directory for this, input 2. Okay, and then let's download those files. So vuln.c and just vuln. Okay, we need to make this executable, of course. And then we need to run the file. Well, okay, let's not run the file first. We should probably investigate the source code. So we got this vuln.c source code. We should understand what's going on in the binary before we start solving it. So vuln.c. Oh, interesting. So it looks like we're dealing with Okay, so the first thing that I like to do when we take a look at the source code for these binary hacking challenges is identify any vulnerable functions. So vulnerable functions are stuff like the string copy that we identified in the last challenge, stuff that's memory unsafe. So we see that system is being used as well, so this is another thing that we need to look out for, because system is going to run an OS command. This runs in OS command. Okay, and we're just making some comments inside of the C code here. I mean, I suppose we don't really need to worry too much because, you know, we don't need to keep this C file afterwards. And scanf string copy is another vulnerable function. This is a memory unsafe function. And what else do we have? So it uses scanf to take in your username. User controlled input. So where does it use this username? So where does it use this username variable? So hello something, your shell is in string. So username and shell, see these are two variables that are being used by the printf function. So username is whatever you supply as the username, and shell is where? Shell has been given 28 bytes. Where do they define the shell? So this runs an OS command, but where is the value of shell? Thank you very much for following Shrexophone Enjoyer. Shrexophone Enjoyer. String copy. Did the chal. Oh, you did the challenge. You finished it already. I guess you're pretty fast. Okay, so where's shell defined? Shell is given 28 bytes here. String copy shell. Oh, okay. So bin pwned. Bin pwned is copied over to shell. So bin pwned is the name of the program that's run. I mean, Xmetric says I mean most modern Linux will prevent it. Are we talking about puts bin pwned into shell? Yeah. The thing is that yeah, most modern Linux environments are going to they're going to have a bunch of protections in place that protect the systems from these kind of simple overflow attacks. Okay, let's save this out. Let's run the binary vuln. Username at this address. Shell at this address. Enter username. Is this being interpreted as C Linux my beloved? Enter username date. Wait. Really? Hello date, your username is at bin pwned temp input 2. Temp input 2. Why does it give you, I mean, this is the directory we're in. Why does it print that out? So your shell is at bin pwned. PicoCTF, are you finished the challenge already? Okay, let's, yes. Oh, awesome, awesome. Okay, so let's try to understand a little bit more about how the binary works. So your shell is at, well, okay. So I think this, if this is a buffer overflow attack, then what this is doing is a heap buffer overflow attack, because the stuff that's being assigned is inside of the heap. So malloc makes sure that whatever is being initialized there is in the heap memory instead of the stack memory. So if we just run the program and we just give a bunch of A's. Hello AAA, your shell is AAA. AAA not found. So I guess what we need to do is we just need to count the number of A's here, and then we can, so echo -n all these A's and then do a word count. So this is 51 A's. So after a number of A's, it's going to enter the shell. It's going to enter the shell variable. So it's not 51 A's, but it's rather 48 A's, because it looks like there are 3 characters that entered the shell variable. So let's go ahead and subtract 3. So now it says your shell is blank. So after these A's here, we can put in our own command, right? So let's try this. Okay, and then run vuln. Your shell is who am I, and then it runs the who am I command. Okay, I mean, yeah, we should be able to just give this number of A's. I think we can probably do this with Python. Well, I mean, we can just do this with our custom payload here. Okay, so we can start playing around. And PicoCTF, yeah, this is kind of cute. So the important thing that we need to understand here is that it's this isn't a stack buffer overflow anymore. It's a heap buffer overflow, because we see that variables that are initialized using the memory allocation are put on the heap. Okay, so this is the binary, or the thing. How do we identify how much to put in for this? So if we wanted to find out exactly how much, well, we need to do a little bit of experimentation. So we know that the memory allocation is at least 28 characters, but we might need more than 28 characters to overflow from username over to shell. So we're supplying at least 28. But you know, the other way we could do this is we could use a pattern, right? We could use a program to... Okay, it looks like somebody has left a random YouTube link. So it allocated to 28 characters in C, so there's usually a bit more. Yeah, so the way we could find out is we could send a pattern. It's 10 hours of Shrek, is it now? Well, okay, so I think we can use a tool like, what is it called again? Rag2, and we can get a predictable pattern by providing, I don't know. So 28, well, we would normally double 28. So that's like 56? 56. Okay, and this is the predictable pattern here. Ah, Shrek, okay. Alright, so we just copy this and then we feed this into the binary here. Okay, your shell is this. So we would grab this, which is in the variable that we're controlling here. And then we would run the rag program again, but with Q. Need hex. Oh, okay. Oh, I guess we need to transform this into hex. Just a second, everybody. Oh, Shrek playing the saxophone. Awesome. Wait. Can we... Okay. So this is... We need to translate these into hex characters. ASCII to hex. Paste this in. Get this. We need to give it a prefix. Okay, so it says Big Endian 48. It was exquisite. Wow, PicoCTF, that's great. Anyways, okay, so with this tool here, we can figure out what the offset is. So the offset is 48, and we can probably create the offset, or we can create the payload with something like Perl print A equal to, I don't know, 48, and then add something else. Then add, who am I? And we can send this to the whatever challenge or whatever netcat command we wanted to. In this case, let's go over to the challenge. It's probably reset by now. It resets now. All right, let's reload the challenge. Okay, and restart instance. Green bottle, hello, nice to see you here. Okay, we got our netcat command again. We're just gonna copy it, and then we're gonna go here. Okay, so, I guess it didn't exactly enter the username. I think the reason why it didn't enter the username is because we didn't include the new line character. So we need to include the new line character. It's hex 0A, I think. Yeah. Hello, your shell is who am I? Your shell is who am I? Enter username CTF player. Wait. I guess this is where the who am I gets printed out to. So instead of who am I, let's give another command like lsla. NRT, hello, nice to see you here. What is up? Which OS? Wait, Green Bottle asks, do you happen to know how to recover deleted files or overwrite overwritten files? Yeah, which OS are you referring to, Green Bottle? Okay, so we got we see that there's the flag.txt in here, and the last thing we need to do is just read the thing. So just replace this part with cat flag.txt. And wait, why didn't that work? We see there's flag.txt in here. We tried to run the command cat flag.txt. Oh, okay. I think we need to give the absolute file path for the cat command. Windows 10. Okay, nice to see you. Good luck with your pwning. Thank you. I'll add some important text notes due to being overwritten because of similar names with no warning. It might be, well, I mean, I don't think it's the space that got in the way because we were able to run LSLA. Actually, wait, we only managed to run ls. Yeah, it ignored the LA part of it. So I guess all we need to do is, well, we need to run, like, we can't include spaces. Or maybe we can. Maybe we can include this. Maybe we can't. Maybe just try calling bin bash. So I wonder if we can just do cat bin bash. Doesn't seem to work. Okay, so ls gets us flag.txt. So there's flag.txt in here. Any ideas for recovery? Because it's Perl, it works with netcat. Any idea for recovery? So Windows 10. So I mean, there's probably some sort of file recovery utilities out there. I've never had to do it myself. So let's see. Bincat. It is bincat for, hold on. Locate which cat. User bincat. It's probably in user bincat. So let's do user bincat. You know, it's funny. I think I think there might be a limit to the number of characters we include here. Maybe we can do cat star. Nope, that doesn't work. So ls works. Cat doesn't work. LSL doesn't work. It probably ignores everything after everything with the space. So in this case, well, okay. Let's try what Panko suggested and just use bin bash. So we just run this, and then we just paste in this with bin bash appended to it. We might be able to get a shell. Okay, let me copy this, and then we will paste this in. Okay, and now we can cat the flag. Done. Interactive shell, much better than nothing. Yippee! That's exactly what you did, right, Punko? I'm just guessing that's that you just used netcat and then pasted in the payload. All right, let's submit the flag. Yup, no worries, no worries. Okay, let's do a very quick summary or a very quick what is it called? Write-up. So binary hacking. Let's create a new file for input injection 2. Okay, and for each one of these write-ups, we want to include certain information, the URL, the concept we need to understand the challenge, and the method of solve. Okay, so let's see if we can get... So the link is over here. The concept we need to understand here is heap buffer overflow. So we're overflowing the heap, the memory heap, and not the memory stack in this case. It's still going to be a variable overwrite. Okay, and buffer overflow, variable overwrite. It's basically the same thing, but let's see. I'll include the code as well. So let's see, source code. Where was my command that downloaded the file? Because I need to overwrite it. Mul.c.1. Okay. I like it when the code is nice and short and I don't need to wrap my head around everything else that's going on. Alright, source code is here. Okay, so the method of solving this one in the source code, we see that the system command, system function, is being used to run the shell variable. The shell variable is set to user bin pwned or bin pwned. By default, using the strcopy command or strcopy function. Okay, and then we have a user-controlled variable called, what is it called? Username. Username, which is recorded by the, what is it? By the scanf function. Okay, and we see that both both username and shell are initialized on the heap. Shell and username are on the memory heap with sizes of 28 bytes each. Guess I will show my homework here. So if we are able to, okay, so username is being recorded by scanf, and scanf is another memory vulnerable function. So let's see, if we just look this up, scanf C function vulnerable. Okay, the C scanf function is widely considered vulnerable due to its potential to cause security issues, primarily buffer overflows and format string vulnerabilities. So scanf is the insecure method of recording user input. For here, and scanf records username, and username is allocated 28 bytes on the stack. No, on the heap. If user input in excess of 28 bytes is recorded, the excess will be overflowed into the memory heap. The goal is to overflow into the shell variable and overwrite its contents with the system command we want to run. Okay, and the other thing we can talk about is getting the offset. We can get the offset to reach the shell variable using the following program or the following command to create a predictable pattern. Predictable pattern of characters. Okay, that's the rag2. Okay, the output of this command. Let me just double check that this is the correct command. Was rag2 this one? Yeah. So capital P dash R. Capital P dash R. Don't get it twisted. Okay, so we can feed the resulting string into the program. then take the value of shell and convert that string to hex. Then use this command to get the offset. Boop, boop, boop. Where is it? This. Hack Smarter, hello! We're just doing a little bit of binary hacking over here. And you know what? It's another InfoSec content creator. Let's give Hack Smarter a shout out. Tyler, yeah. So Tyler, otherwise known as Hack Smarter, does he does InfoSec live streams. So he's been doing a lot of co-working stuff lately. And I think he also does walkthroughs and demonstrations as well. And HackSmarter also has a new platform, a cybersecurity platform out right now. I think it's called hacksmarter.org. Yeah. Let me leave the link in the chat. There you go. Okay, Hacksmarter says, I taught an 8-hour live web app pen testing class for TCM today as an instructor. My brain is fried. Wow. I didn't know. That's awesome. That's awesome. Let us know where we can find. Was that a free class? Is it on YouTube, or where can we find that? KairoSec. Yeah. KairoSec is the name of Hacksmarter's company. Not free, it's quite pricey. Oh, well, okay. Good to know. I mean, I'm sure you're not teaching. I'm sure you're not teaching for free. Anyways, let's go back. Okay, so we find out the offset over here by analyzing what we see in the output of the binary, and then I get paid a set pay as a contractor. Is it? It's lump sum, right? They pay you once, and then they get to use your materials that you provide to them, or is it something? Or is it paid like per student? I'm not too sure how that would work. I mean, if this is confidential information, you don't need to tell me about it either. No worries. Okay, so. Use this command to get the offset. This one right here. Nope, that's not it. Where was it? This one. Good old rag. Okay. NDA review. So from here, we just need to we can send an offset, send the appropriate offset, then end it with the bin bash command to open an interactive shell with the server. Okay, so something like echo, no, what's it, Perl E print A times 48. Yeah. So A times 48 plus, actually, so this is just to create the offset. And then after that, we need to tack on our bin bash. Bin bash. From there, read the flag, .txt file, and we're done. Okay, so let's hold on. Okay, looks like we're going to be moving on to the next topic. So what is going on now? So topic 3 is done. Topic 4 is here. Oh, Shinbier, you got to go to your IT Expo today. Awesome. Yeah, have fun at your at the IT Expo there, and hope to see you again in chat sometime. See you later, Shinbier. Okay, so right now we're going to be checking out a new platform. It's called Standoff365. It is a Russian cybersecurity platform, cybersecurity education platform, and they've got a really cool like multi machine network that anybody can hack against. And we have been having a lot of fun trying to figure out the secrets of the network. So that sounds cool. Yeah, it is really cool. You just need to sign up for the service, and then you go over to, I think it's Hackbase Bootcamp. So the bootcamp is it's basically a multi-server network. I think there's like 14 servers exposed on the network, and you can hack against them all. It's kind of it's a lot of fun because I think the machines have relationships with each other. So you need to pop around from one machine to another to get all the stuff. So you download the OpenVPN file, and then you access, I think they've got a network range. It's free, yeah. There's paid content on the site, but let's see, Bootcamp. So Bootcamp is over here, and they've got a network range that you can scan against after you've logged in with after you've VPN'd in. What in the world? I need some I need some Russian money for my infrastructure. I mean, it'd be kind of rough. I think it would be kind of costly to host this kind of setup on like AWS or something. But yeah, this is how, well, let's go ahead and start the thing. Okay, we don't need this anymore. Here's my VPN connection. Looking forward to watching. Yeah, I mean, you can, well, I mean, if you got some free time, you can try this out yourself. You can challenge yourself. If you want, I'll show you just some fun highlights about this. And where's my VPN key? So Standoff Battle 7, OpenVPN. Working now, we'll watch. Awesome, no worries. So we're doing Standoff. Okay, so they want, I'm pretty sure this is one of those rare VPN keys where they want you to log in when you're using the VPN key. So I'm going to go ahead and do that. Panko, how are you doing for sleep? I know it's like super late where you are right now. It's got to be like 3 or 4 a.m. You're not staying up super late on account of watching this stream, are you? Hope not. Okay, so Standoff365. Let me get my credentials. So it is, I think that my username is the Shy Hat. And let me get my password. Okay, so I should be connected now. And can go ahead over. Okay, so I've mapped out a bunch of the web hosts in this IP list. So the IP list is these IP addresses here. We found them by scanning through Nmap. So we've done a bunch of initial scans, and we've written a lot of notes about the different hosts. Wait, this is the wrong file. Yeah, it's this one, netoverview.txt. Just a second. Okay, let me go ahead and rename my tabs. Oh, you know what? We should give ourselves a time limit, because we don't do these things forever. Everybody, thank you very much for sharing time and watching Silly Hacker on your Friday evening. Let's do 2 hours, and we'll see what we're doing, what we're up against after 2 hours is done. Okay. What were we doing? We were taking a look at the overview. Is it not? Oh, I'm in the wrong directory. Here. Okay, so we've flashing some PIS. PIS? Oh, some pies. Okay, I thought you were talking about something different. Oh, well, as long as you're having fun, Panako. Okay, so we've recorded a bunch of information about these different targets. So some of them didn't have TCP ports. Most of these targets have port 80 open, and I think each one of these targets is hosting a different website. So this one is hosting library.edu.stf, and another one was hosting like the WordPress site. This one's hosting something called Heavy Logistics, and it's also got an FTP port open apparently. So I don't know what the heck is going on. Oh, we also found some email addresses on this web port here. So somebody told me, well, okay. Let me close out Burp Suite, because I think that there's some sort of memory leak associated with that. Okay, so getting access to the services. There are different ways to get access to the services. You can do one of the following things. Directly hack a vulnerability on the service on the external perimeter. Obtain access to the VPN config file pertaining to the internal network. So we need to be on the lookout for this. So we're on the external network, but this says that there's an internal network as well, and that we need to get access to a VPN config file. We need to be on the lookout for this. So the other thing is that we can find employees' email addresses and send them phishing emails with a malicious payload. I'm actually really excited to do this because I've never done phishing stuff on any of my previous CTFs. Thank you very much for following Van Flickle. Van Flicky? Not too sure. That's going to be fun. Well, I hope so. The thing that we found some email addresses. I think we found them on this host right here. So we found 3 email addresses. We could potentially do some phishing against them. Van Flick, the final E is silent. Okay, no worries. Thank you very much for telling me about that. You know what? Let's give you a Nyan Cat. Welcome to the stream. Okay, so the only thing we need to do is even if we have email addresses, if we don't know where to send the emails, we're kind of lost. So we need to look around. So this says admin dashboard, test server. This is the DNS server here because it's hosting port 53. And I'm pretty sure I saw that there was that it was using that other servers were using this server for DNS. So I just need to figure out which one is hosting the which one of these servers is hosting the email service. The other possibility is that we have to access like a web-based mail, which means that we need to find the server with the email form. So we haven't checked out this endpoint yet, so I'm just going to check it out now. So for each one of... Oh, where are we? Here. So for each one of these hosts, I've created a directory that has all the notes regarding it. So let me go ahead and enter this directory here that we're going to look at. So the only thing I've recorded for this particular server is the GoBuster results. So we got test.txt, which is size 0, and the echo endpoint, which is size 0. This looks kind of suspicious. The index page is a PHP page, so we might as well check it out. Okay, so this, let's check it out here. Just go over and site is wrong browser. Maintenance is in progress. We apologize for any inconvenience caused. I mean, it's given us a wrong browser. What browser are they looking for? It just says wrong browser. I mean, we could change our user agent, and maybe if we change the user agent, we can see some extra stuff. So let's grab the IP address, the URL here, and we'll try using some curl. Curl. Okay, so does it still say wrong browser? Still says site is... It says use other browsers here. So if we use Firefox, it says wrong browser. But if we use curl, it says use other browsers. Title is offline. Well, I guess we need to spoof our user agent then. Okay, this means we need to use some, what is it called? Some FFUF. Can we use FFUF to FFUF to this URL, and we can send this custom header user agent? Actually, wait, FFUF probably has its own user agent. It has its own user agent tag. Let me look that up really quick. More enumeration while that runs, the txt file. Yeah, I think we can look for the extra stuff while that runs. I just want to know what the... So H is for header value. You know, Punko, you use a lot of FFUF. You should probably know this, right? Not that I'm calling you on or anything. Okay, so is there one for a custom user agent? Input options. I guess I can just use a custom header. Okay, FFUF. Yep, we're using FFUF. It's a lot of fun. User agent fuzz. think you ran with the word list on headers. Run with Happy Friday, everybody. Happy Friday. You know, it sends it with the FFUF user header. Okay, let me try getting a list of user agents. Where are we? Okay, I should probably rename this session, or rename the tab. 124 1242. Okay, so locate. So inside of sec list, there's probably something for user agents. Sec list fuzzing user agents. What is my browser.com mid, large, and small? I think we should start. We'll start small, and if we don't find anything, we can move on to the larger ones. What is my browser.com? Interesting. I didn't know about that. Okay, so word list is here. Okay, so what did this return? So size 616, we can probably filter on that. So filter size 616. And see if there's anything that doesn't return, that returns something else. Oh, we found something. Huh. Okay, so what returned? So 611. Okay, let's just manually try one of these. Petit potam for everyone. J-Bad, hello, nice to see you here. Okay, let's try the curl command again with this custom user agent header. Let's see what comes back. Bad request. Wait. Oh, I think we need to put this between some single quotes instead of double quotes. Oh, you know what? I think we need to put this. We need to reorder this. Okay. We'll put the headers before the URL. Still gives us bad request. Oh, okay. It's because I forgot to put user agent in there. Jeez. User agent. Yeah, Alexander, you're right. Okay, it still says wrong browser. So wrong browser and use another browser. Masterism is test.webserver.edu.stf. Test web server. Is that what came back? Hold on. Is this one the test web server? I know I think there's a list of the different domains out there, but I'm not too sure where to find it. Okay, so FFUF. So this one is 611. So we're filtering on 616 and 611. Can we filter on? We can filter on more than one, right? Or do we do it like this? It was the second result. Oh, no spaces, just comma. Oh, okay. Panko would know. Panko loves using FFUF. Okay, so we didn't find anything. Second result. Really? FFUF, my beloved, of course. Okay, let's just use a really big list. So the really big list is the large one here. Let's just get that. You're sliding too fast. Hold on. Okay, we got a lot of user agents here. So user agent fuzz is looking for a custom admin dev agent that you need to enumerate out if none of these work. Yeah, maybe. Let's move into another directory now. So the GoBuster stuff says there's the echo endpoint as well. Maybe we can check out the echo endpoint. /echo. Nothing appears. What is... I mean, what's going on with this thing? 10.241.242 echo. I just want to see if there's some sort of custom headers that are returned here. 10.124.1.2. Okay. I think nothing returns. So we're looking at the echo endpoint here. 10.2.124.1.242. Nope. Yeah, so just nothing returns. Oh, did I do it wrong? Oh, I did do it wrong. IP address, thank you. Panko Panko, very useful chatter, thank you. Okay, so not found. Not found. Completely sent off. So it was sent off. It's a legitimate endpoint, but nothing... Are we supposed to echo something? Echo, like maybe command equals something something? I don't know, just for fun. It was sent off, it comes back okay, but it doesn't do anything. And it doesn't return anything. Alright, well. Okay, we finished. We finished with the FFUF command. It didn't return anything. So all of these are incorrect. So Masterism, you mentioned something about what was it? A domain. What command was I running when you saw that? So wrong browser. Offline. So it says wrong browser. The other one was... If we just use the curl browser, or the curl user agent, it was when I used FFUF. Really? Use other browsers. Okay, so when I ran FFUF with... It might have been this one. So it was part of this output here? It showed up at the bottom when you ran curl getting an error. Really? Curl this one. No, this is the correct user agent. The error one was the one where I didn't include the user agent. Oh, you know what? That's funny. That's no, I mean this is a bad request. So this was part of the yeah. Okay, so testwebserver.edu.stf. That's not challenge. Well, no. It is challenge related because we probably need to enumerate all the domains. So let me add this to our domain list. Sudo nano, etc. hosts. So this one is, what is it? 10.124.1.242. Okay, so we've enumerated these different domains. We just need to, well, let's get rid of this. This is not relevant anymore. Okay, so now that we've got the correct domain, we might get some additional information by visiting the website. So what is it called? Test web server dot edu.stf. Okay. I thought that was a challenge infrastructure. I think, well, I mean, part of enumerating the stuff properly is using the correct domains. So now that we've got the correct domain, we might want to run an additional, like some additional web scans. Let's use some nuclei. Okay, and then we'll just wait for this to come. Well, we're not going to wait for it to come back, but we'll just, let it run. So what else was on the GoBuster list? tst.txt. tst.txt. It's weird that that would be a thing, but let's give it a shot. Was it test web server dot edu.stf? Yeah, it comes back okay, but nothing comes back. Okay, so if we go back to nuclei here, it still hasn't returned anything. That's okay. So text plain. There's also the JavaScript directory, which is redirected. I'm guessing that this doesn't actually give us access, but we can give it a go. So JavaScript. Forbidden. Okay. So this is... I think this has something to do with, what is it? Like web application firewalls. So there's some sort of web application firewall that's running on this thing, and it's blocking a lot of our stuff. So if we run whatweb on this thing, did you already check robots? Well, we can check it right now. Title offline, yeah. So I think what we need to do is we need to find a filter or like a bypass around the web application firewall. So robots.txt doesn't get us anything. Yeah, not found. So I think the first thing we need to do is we need to figure out what user agent header we need to send. Okay, so WAF detect Apache generic. This is port 22. Have you used Zap proxy? Sometimes it's kind of useful, only sometimes. Only sometimes. Well, I mean, most of the time we're using... So are you using Zap proxy for its scanner tool or for like burp-like functionality? Let me know. So which user agent, what user agent is it looking for? Curl and use agent test web server. Oh, that was the wrong endpoint. We should be sending it to index.php. Use other browsers. Depends, sometimes I use burp, sometimes I use Zap proxy. I hear ya. Okay, so use other browsers. We don't know what the browser is. The good thing about these challenges is that there's like 14 targets for us to look at, so if we get tired of looking at one, we can look at another. Okay, so it found a bunch of missing security headers, but it wasn't able to find much else. Is it only wanting Firefox? I'm not sure if I'm not sure what it's looking for. All I know is that when... So the thing about the error that we found is that the only reason why we saw that error is because we returned a 400 error. And we returned the 400 error because we sent it some weird data. Where's that weird data? Try using SQL injection or command injection on the user agent. On the user agent? So we sent, you know what we could do right now? We could probably find out the host names or the domain names for all of the targets. We just need to send it, you know, like some funky malform stuff. Just sub out the what is it? The IP address. So for example, we don't know what actually we know what 4.2 is. So we now know that 4.2 is the test web server .edu.stf. So we could probably find out what there's only port 443 open on this other host, 253. Let me check out this one. So 253 Okay, we didn't get anything from here. So it says, yeah. So curl wasn't able to find anything here. If we switch it over to regular HTTP, there's just nothing running there. What are some of these other targets? So this one is smashmusic.edu.stf. Did we add that one? I don't know if we did. Let me do a quick check. So we found Smash Music, we found Test Web Server, we found Library and WP. Is that the only vhost? I mean, I'm not sure. I'm thinking that most of these IP addresses are only serving one subdomain. No worries. I mean, we're all struggling with web app stuff because there's a lot of web app stuff out there. Okay, so what are some of these other hosts that we haven't identified? So 240 we don't know. It says that this might be the test authentication server. 239. So let's try this with 239. Okay, so we this is a really funny way of enumerating the domain names, but this one is called Tokenizer. Can you share the link for this challenge? Yeah, it's on this platform right here, Bootcamp. Whoops, reload that. It's called Standoff365.com. Okay, and what did we just find? This one, Tokenizer. So this one is Tokenizer, and it is 239. Okay, and let me just grab the rest of these while I'm at it. Okay, so the 239 is Tokenizer. Okay, and what about this one, 238? Let's figure that out. 238. This one is shop.edu.stf, and this is 238. Okay, and let's take our notes. So shop.edu.stf. And we can figure out what this one is with the PDF converter. So 237. What? Sorry, why did this not send me an error code? So this should have sent me an error code. I think there's something wrong with the server. You can send it basically anything, and it'll return something. Let's just send a bunch of special characters and see if it manages to break. It doesn't care. It doesn't care. Okay, well, I'm looking at 237, right? 237 info.php. Let me take a quick look at this in the web browser. There's just too much stuff to look at. Oh, okay. There's a PHP page. You know what I really want? I want some sort of tool that goes through the PHP info output and grabs a bunch of information from it. Like maybe important information. Okay, so this one is called utils. utils.edu.stf. Okay, let me grab this. Right. Let's record it. And 237. So this is the utilities server. What else do we have? I think there's like one or two more that we need to enumerate. 236. Okay, we'll do 236. Gallery. Okay, this one's called Gallery. Okay, so 236 is Gallery. All right, and are there any more? So this one's called, well, the page is called Heavy Logistics, but let's find out what the actual domain is called. So it's 235. This one is actually what? This one's called www. This one's called www. Okay, let's record the info. 10, 124, 135. Okay, and this one is WP on 234. We've already recorded this. It's out of order. Let's put it in order then. Okay. So 233, 34, 35, 36, 37, 38, 39. 40 is not, there's no web server on 40. Let me double check. So 40 has only port 22 and port 53. We could probably do some DNS enumeration on this server. But I haven't done DNS enumeration in a really long time. I'm not really sure how to do it. Okay. So this one, this particular server had a really funny port. We were able to completely compromise this server. We were able to get, root access to this. That's the DNS server. Yeah, that's the DNS server. What I really want to do is I want to figure out where we can send our emails from. So this is Tokenizer. That's the shop. This is the utility server. This is the gallery. We haven't checked out the gallery yet either. So we're not really getting anywhere with the test server. I don't know if we should keep on doing this or if we should move on to easier targets. Not sure. Okay, what about the other targets here? 236. We haven't taken a look at this yet. So 236, this is a gallery. So if it's a gallery, that kind of tells me that there might be some sort of file upload. That's just kind of a guess. 10, 124.1.236. It is 236, right? Yeah, for the gallery. And we've got our initial GoBuster here. Classes.php, ajax.php, index.html. We also have an images. Red Team Rookie. What's my boy Shy Hat doing? We're doing a very large network challenge over at what is it called? Standoff365.com. It's a really big network. It's got like 14 different servers running on it, and we're just slowly trying to enumerate the thing. We've got a list of different servers, IP addresses. We're taking a bunch of notes, and we're just trying to poke around at the thing and figure out where we can actually get our attacks off. Okay, so let's take a look at this gallery then. Whoop. Okay, so what is this? This is supposed to be like an HTML. Ooh, there is a file upload page. You know what that means. Is there buffer overflow too? Not sure. There might be buffer overflow running on one of these services here. What happens if we click on this? Oh, we can look at the pictures. What is this? Who uploaded this? Okay, we can take a look at these pictures. So I'm guessing we should be able to, you know, upload some malicious files and then get command execution. So it looks like, is this how we upload the files? Load images. Okay, so we should probably load up our burp suite, because we're going to be doing some intercepts. Well, not intercepts, we're going to be doing some repeating. Okay, so normally when we do this kind of file upload attack, we want to find what the baseline is. What does the application accept? So we're going to be doing this through the Burp Suite browser. Gallery.stf.edu.stf. Okay, so this is how it loads in the images. We got upload new, choose a file. So choose a file. We have our sample PNG over here. Select. Why does it want us to submit a web page? Upload new. Choose a file. Oh, wait. Is it either or? Can we... Oh, we were just looking at this like the other day. This might be server-side... What was it? Server-side request forgery. Okay, so just for fun, we'll host a file over here. Okay, so Python host the thing. What is our IP address? We need our IP address if we're going to be doing some attacks. Here's our IP address. Okay, so I'm just going to create the payload over here. So we need to do our IP address and, was it 1 1x1.png. What is the name of the file? Just a second. It's called example image 1x1.png. Okay. Grab that file name, and this is what we're going to supply as the URL over here. Submit. So what happened there? It didn't tell us what happened. Oh, it got submitted. It got submitted. Interesting. Okay, well, let's take a look at what happened in Burp Suite. So let's see. We got our post request to Ajax, and action get image list, upload image, and it gave us a get image list. Okay, so let's go ahead and send this to the repeater. In the repeater, we've got this over here. So upload image, and then image file name. This stuff is blank. Image URL. This is here. What do we want to do? We want to, was it like localhost or something? Actually, what is this page? So this page is index.html, right? Yeah, so this page is index.html. Are there any other pages we would want to look at? I guess we could look at other servers. Not exactly sure. Let me put on some new music first. So the other thing that we saw about this particular machine, let me change the title. 10.241.236. There was a classes.php page, server status 403. There was an images directory. We probably can't look inside the images directory. Okay, we got ads running on Twitch, so run them on YouTube, and we put on the birds. Okay, everybody, here are my favorite birds. Enjoy the birds. We'll be back in 60 seconds. Just need to take a little water break. Okay, let's get back to the hacking. So can we just get can we upload other files? So we go back to Burp Suite and replace this with something else. Let's say localhost port 80. I don't know. What other ports were open on this target? On this target there was only 22 and 80. So we don't know very much about this. We should probably add to the notes. There's a file upload function which takes in URLs or files. So potential file upload attack or SSRF, server-side request forgery. Second the mind, hello, nice to see you here. What is up? You've seen me do this this network before, right? Second the mind, I'm back to the edu.stf. Yeah. I'm just trying to keep track of who knows about this platform. It's a very good platform for it's awesome starting enumeration. Yeah, I mean, I think if you wanna have a lot of fun, you can try this out yourself, because there are so many hosts to enumerate on this on the network. Okay, so we're currently looking at the gallery. And we're trying to see if there's server-side request forgery on this thing. Localhost index.html. Let's just pretend send this request. It's probably say something. What? Why does it give me this response? Images /images something something something.txt. Okay. What happens if we navigate to this? This is weird. What does this say? This is a copy of the web page. So we can do server-side request forgery. So if we just try to navigate the images, it's probably going to give us a 403 forbidden, right? No, it just doesn't show anything. Okay, that's fine. So we can use this to access other servers, maybe. My first go-to for SSRF is file. File? Well, I can give it a go. Let's go back to the request. So instead of HTTP, we do file, etc. password. Yeah, let's give it a shot. Can we do, is that // Okay, well, it gave us a link. I go straight for the host, then if no, move on to see what I can see through the looking glass. Let's see if this worked. If this worked, then it is really cool. See what happens. Wow, it worked. Jeez. All right, well. And I think I see these same users. I've seen the same users on another machine. Well, there it is. Jeez. All right. Well, let's add this to our notes. there's SSRF that will... You can get some basic users for the environment. Yeah, I mean... I've seen these users specifically on the other box that I compromise on this network. So let's talk about this. So common users, common server users. These guys over here. No shot, etc. shadow is readable? I don't know. I guess we can find out in just a second. Think you can grab the host file? Yeah, we can give it a try. Okay, we can go back, go to the requests. Where's the request? Our request is here. Okay, file etc. password, file etc. hosts. Host file name you get grabbing a Linux host in that environment might not be as useful. Probably have a dedicated DNS server for it. I think, well, just for fun, we'll take a look at this thing. Where do we do it? Over here. It's a bit slow and steady, but that's fine. Okay, so it's just got reference to itself. So gallery.edu.stf. I'll test to see if we can access the shadow file. Actually, we got in... You know what we can do right now, before we do anything else? We can do some password cracking. Because we got the shadow file and the password file for another host. Which one was it? We compromised this one right here, 241. Let's go over to 241. Okay, so we got the password file, we got the shadow file. If the shadow file is readable, it means the SSRF process is running as root. That's true, otherwise it wouldn't be allowed. Okay, so we can do unshadow. It's the password file first and then the shadow file, right? This is how we do it, right? I don't quite remember. Okay, so now I just need to figure out how to crack hashes against Linux Linux shadow files. I can probably find a tutorial online. $6, is that going to be a problem? Cracking Linux password hashes. The prefix for the hash. Okay, so if anybody in the chat has a working command, I'd really appreciate it. For example, well, I mean, so this is all going to be 6. SHA-256, SHA-512 crypt. You can pass it to Hashcat. Those were user passwords, right? This is, I mean, these are password hashes over here in the unshadow file. Rupan Kar, hello, nice to see you here. Welcome to the stream. Have a hack the planet on me.
Hack the planet! Hack the planet! Shut up and get in.
Okay, so SHA-512 crypt. Guess we can look it up real quick. Hashcat SHA-512 mode. Okay. So looking for SHA-512 crypt. Hashcat SHA-512 crypt. Well, let's take a look at the help thread and see if this person got help. If you're using the full first example, you need to use the add the username command to the what? So this command is okay. Command line hashcat. What? Second in mind, let me grab your message there. A0M1800. Okay. So I'm pretty sure I ran hashcat pretty recently. It looks like it didn't record it in here. What are you doing? I'm on my first year of IT. Hello, Eli. Nice to see you here. A0 is the word list. Okay, so I mean, if we're using word list, that means that the word list should be rocku.txt, which is our favorite. Oh, A3 is brute force. Brute force. I've never really used brute force before. I've never come across a scenario where it really came in handy. Hashcat. Okay, Alexander says, almost never worth bothering cracking bcrypt hashes unless you have good inclination that they're crackable. I also don't have such a great let's see, I have it for pentest engagements. If none of my word lists catch it, I'll use A3. Oh, interesting. Okay, let's take a look at this hashcat. It is okay. Unshadowed.txt and then the word list. User share word lists rocku.txt. Okay, it looks like it's bcrypt is annoyingly slow. Good to know, just in case I come across it. But what does bcrypt look like in as far as the indicator is concerned? Is it like $8 or something something? Not sure. Anyways, we got this running over on. We'll just call this hashcat cracking. Okay, so this is running, and let's take a look at the server-side request forgery stuff. Repeater. Let's just take a stab in the dark and see if we can look at the shadow file. If we can, well, if we can take a look at the shadow file, it would sure would be something. Is that password literally word? You got one. Did I? Did I? Okay, let's try taking a look at this shadow file to see if it actually, you know, comes through. Not found. Okay, well, I guess it doesn't exist. What did we find? Word. Password? Password. Password? But how do we know which user this is? Hold on. Let's grab that one from the unshadow. Yeah, I guess so. Let me grab this. Yeah. Okay, let's do it. What server was this? So hash cracking is on 241. Okay, and the unshadowed grep. Waiter. Actually, I knew about this. I knew about this one. This is the account that we used to get into the machine. So I guess it's not really a new one. But RM, hello, nice to see you here. What is up? Hashcat-h gives you all hashes grep for what you need. Yeah. Well, I mean, you know, let's see. Did we find anything new? And I'm not too sure what this token length exception warning is. This error happens if the wrong hash type is supplied. Oh, I think the problem here is that there's no hashes for these entries. Yeah, there's no hashes for these entries. We found one, which was the password one, but we'll just keep this running in the background. Okay. You have the whole password entries in there. I mean, we should have deleted the stuff that that didn't have any hashes, but I guess I forgot to do that. Okay, so what else can we do? So we managed to confirm the SSRF. I guess we could look at files that we wouldn't normally be able to see. We looked at the password file. We tried looking at the shadow file. We tried looking at the host file. I guess something else we could look at is what other files could we snoop? We got basic file read access. Yeah, but we don't have elevated access. So file. There's a web user. We saw it in the. Hold on. I want to get a copy of the password file. let's just get this again. Okay, let me just copy the whole thing. And let's see, this is, which host is this for? This is for gallery, okay? And gallery is which one? 236, okay. So here we are in the 236 directory. I'll just create a password file. So I think the unique user for this box is this web user. So we could probably try to snoop this user's SSH password or SSH passkey, or their public key, rather. No, their private key. Let's give it a go. Okay, so that would be file home web .ssh ID RSA. Okay, let's give it a go. And this is probably going to be not found. Because the other results gave us really long file names, but this one's really short. Yeah, not found. Short means failed. Yup, looks like it. I guess we could look for the IDRSA keys for other users as well. Try the other ELG. What are the common names? SSH private key common names. So there's like EC something something and some other ones. ID, yeah, these ones. So DSA, EC, DSA. I'll give it a try. What's the worst that can happen? You get a really short result. Okay. That didn't work. How about this one? I'm lazy, so my go-to right now would be to create a Python script to fetch the end result. I think, yeah, if I wanted to do this programmatically, either that or use some sort of well-known tool with Bash. Yeah, the thing is that we've got these ones right here, and we could probably, well, they all have home directories. Yeah, so let's check in on the hash cracking. Hash cracking still going. Otherwise, we could do this with FFUF. Let's stick with this a little while. What other files could we look for? Copy as curl command and simplify it with the bash script. You have to capture the response and dump the second part of it automatically with the follow-up curl. Ronan, hello, nice to see you here. Haven't seen you in a while, but welcome back to the stream. Hey, we're doing a really big network challenge from this website right here called Standoff365.com. It's a Russian CTF education platform. I haven't gotten hacked yet. Or at least I don't think I have. I don't think I'd be able to tell. Do you need to register? Yeah, you do need to register. You know, hopefully that it is free. It is free though. You know, first hit is free. Okay, where are we? We're just doing some server-side request forgery. We could probably, yeah, copy the file. And this is, which target is this for? Just a second. This is for the 36 target, right? Yeah, 36. Copy the file. We need to go to, we'll call this SSRF request or rec.txt. And then we can start programmatically doing this stuff. So everything's the same, except we can so home web, home fuzz, something something IDRSA. Okay, so we'll just set the fuzz point for this. We'll see if we get any unusual like lengths of response. We have the password file here. The legitimate users are these ones. Actually, can I cat and then cut the colon field 1? Okay, so this is what we want to populate with our list. And I think the other thing we need to do is we need to adjust the file name, because the file name right now is IDRSA. Yeah, okay. This is actually what we want. We want to check if we can find any IDRSA files. So ffuf our request ssrf rec word list is users.txt. Okay, so these all came back with the same result, which means they didn't work. I guess we can go in and we can replace the file name. And to replace it with the other ID whatever names. What are they? So ID this one. Same thing. Okay, replace it with the other one. Oh, you know what? We can get the bash history. Yeah. Why don't we look for the bash history? So home fuzz and dot bash history. Yeah, let's check for this. Redirected to dev null. If it's not redirected to dev null, well, I mean it's something to look for. Okay, well, I mean I guess it could be that all of these users don't have their home directories open. In which case we're kind of sad, but that's okay. What else could we start looking for in here? We could look for the database file. So GoBuster classes.php, ajax.php. I mean, we could read proc self environ. Which one? What does proc self environ get us? Can you? I've seen it before, but I'm not completely sure what it does or what is in there. Environment variables of current processes. Okay, let's play some cyberpunk music. Where are we? Here. Okay. Proc self environ. Sure. Let me copy that. Okay, send that request. It looks like we weren't able to get it. But we'll test it anyways. Yeah. 2 slashes? Now I'm pretty sure I did 3, but let me check. No, there's 3 slashes here. What other sensitive files could we look at? We looked at the host file, we looked at the... There's some PHP files, ajax.php. The index page is an HTML page. There's a bunch of JavaScript files in there as well. Actually, just for fun, I want to take a look at this ajax.php file, just in case there's some funny stuff hiding in there. So that would probably be in var www HTML, but actually it might not be there. It might be in var www gallery.edu.stf, like this. Because that's the way it was. This is the format that was on the other server. Grab the Apache config. Hold on. Let's see if we can get this first. This doesn't look like it came out. How about index.html? Actually, wait. We can just, if it's a web file, we can just do it like this. HTTP localhost. Ajax.php. Whoops. Okay, this seems to have worked. Thought you wanted it not rendered. It's going to be rendered. Oh, is it going to be rendered? I mean, it's a text file. Let me check. Let me check. Oh, it does get rendered. Wow. Okay. All right. So I guess that doesn't work. So okay, if in that case I need to grab it from var www html. Let's see if it's in the HTML directory. It's probably not. No, it's not. Just to make sure, we'll just try index.html as well. Yeah, so this is not the way. Let's see if we can find. So var www gallery.edu.stf. Let's try this. How about etc os release? Did that not go through? Wait, do I have a syntax error in here? File. Oh, okay. Yeah, right. See, if you don't if you don't spell properly, you can't hack. OS release. Okay, now it works. Ubuntu. Yeah. It's Bionic Beaver. That's great. I mean, it looks like a pretty up-to-date version of, a relatively up-to-date version of Ubuntu. Okay, let's check the other files, because I made a spelling mistake. Yeah. Okay, gotta change this. Send. Okay, this didn't work. What happens if we send HTML? Okay, this works. This works. So this is just in the HTML directory. So we can probably get ajax.php now. Here we go. Okay. Okay, and then let's read the thing to see if there's anything special inside. Don't think there is gonna be, but you know, just for fun. Okay, so include classes.php. This is just Okay, so upload image, post image URL, then do it this way. Or else if upload image by file, upload. Uploads to the images directory. Sites enabled. Sites enabled star? Oh, well, I mean, listen. I'm up for anything. What is that file path? Etc. Apache 2. Sites enabled star. That didn't come back. You grabbed the ajax.php while I was trying to find the file. Oh, sorry. Hold on. So uploads directory images array. So it's doing some sort of transformation when it uploads a thing. It's looking for JPEG, PNG, and GIF. I'm not too sure if we can bypass these particular filters. It's checking for the extensions. But I guess we haven't done any testing on the file upload. This is an upload? Yeah, this is the logic. This is the logic, and there's also upload. It's not just SSRF. Let me show you. So in addition to supplying a URL, you can also just upload a file. Ask the AI. Okay, yeah, I guess we could. Let me grab this. Oh, ChatGPT. This is some PHP code for a file upload function. Is it secure? It's not doing a MIME type, is it not? I need to assess a view vulnerabilities in the code. Okay, well let me go back just for a second to see if we've cracked anything. It doesn't look like we've cracked anything or anything new. Okay, we'll just short answer, not secure as is. The snippet exposes multiple risks. Okay, let's reload the page because ChatGPT is very laggy. Short answer, cliffhanger. This thing just sends my CPU through the roof. Don't even know why. Okay, so we'll just leave it alone for just a second and wait for this thing to come down. Oh, Hashcat is sending my CPU through the roof. That's true. Cancel it. Yeah, I guess we can. We're probably not going to get anything from the cracking, and I can always come back to it later. Okay, reload the page. Jeez. Come on, ChatGPT. Work with me here. Okay, so what does it say? It says... well, it says a lot. Okay, the snippet exposes multiple risks, and the real danger likely lives in the unseen classes.php, where the upload logic is. Oh, okay. Here's what stands out now to harden it. URL upload. So it mentions the potential server-side request forgery here. File uploads, RCE path if mishandled. We don't see the move uploaded file MIME validation re-encoding or file name handling. So we know that everything we uploaded turned into a TXT file. It's kind of weird. Executable uploads likely. Okay, allows for JPEG, PNG, GIF, but attackers can upload a file that with those extensions that's actually script content. Polyglot GIF 89 tricks. I mean, I don't know how to do this. I've never done it before. Nothing here shows that the PHP execution is disabled in images. Oh, wait. Wait. We saw that it executed PHP when we tried getting the whatever file. No? Is that not the case? So we tried getting the Ajax file from the web server. Okay, so the other thing we need to do is we need to take a look at the classes.php file. It basically ran a wget localhost ajax.php rendered first and then copied to you, and then whatever text of whatever was left. So it didn't actually run the code inside of a text file. Okay, so because we used HTTP, well, you know, maybe what we should do is we should grab that other file, var www.html classes.php. Okay, send it over. And we've got a legitimate thing. You know, before we do this, let me grab what we have here, and we'll just save this. We'll call it ajax.php. This is 236. Okay, and then we'll grab the code for classes. Okay. So function upload bin to hex. Oh, okay. So whatever, okay, I see the logic. So if there's a lot of stuff in the binary, it turns the binary bytes into hexadecimal characters as a file name, and then it includes the image extension. So the image extension, if it's one of these, then it gives it this file extension. If it's not one of these, it gives it the txt extension. So I guess we would never be able to upload PHP extensions because of this logic in the in this classes.php code. So I guess uploading a web shell isn't really an option. I mean, what can we do if that's the case? And let me grab the code, and we'll take it as our notes. So, what are some other files that might have credentials? We have our fancy. We've got our request over here. So our SFR requests. We could feed in like a big list of files to try to download. Just sub out whatever is in. Yeah, sure can. Okay, so where's a good list? locate seclists. The issue is you're not automatically downloading them, are you? Well, I mean, we're not. I don't think we're downloading them if we. No, it doesn't download them. It just creates a link. We're just checking to see if we get if we're able to access the thing or not. It's only going to create the text file, and it'll give us the text file link, but that's not downloading the file. Okay, so let's LFI. Nope. What? Linux lists. LFI, etc. files of all Linux packages. Default web root directory Linux list. Which one looks good? What is in this list? I mean, it looks pretty good. Okay, let's try this list. Okay, and hold on. Before we do this, I need to adjust my request file. Where is it? File fuzz. I'd honestly created a Python script for that. There's going to be a crazy list of requests to fetch on the tail end. Yeah, maybe. So this already includes a slash, so I need to compensate for that. But let's try running it. FFUF. No. Okay, so we need to filter out some stuff. So the smaller ones, size 18, we need to get rid of those. So filter on 18. Everything else is 50. So if it's legitimate, it's 50. What is proc self command line? Welcome in, NT9V. Hello, nice to see you here. Welcome in. You're now HackerFrog. Hello, this is awesome. I'm glad you feel that way. Nyancat, for you. Okay, so is proc self command line, what is in this file? HackerFrog, nice. Yeah. It's a Linux system. In Linux, it contains the complete command line used to invoke the process that is currently accessing the proc system. Okay, so this isn't necessarily something we're super interested in. We know that we can get these other files here. So we can get etc password, we can get etc host cron tab, issue. But NT9V, are you a cybersecurity student? Are you working in cybersecurity? Let me know, because we're always interested in what is going on with the chatters. Host.conf, hostname. Proc version. So we got the SSH config. Maybe that could be interesting to get. So either the Student in computer science, love anything and everything computing. No worries, no worries. Glad to have you here. Welcome in. So maybe the SSH config? Host.allow. Let's start snooping around. So we're just using some burp suite to replay some requests. We found some sort of vulnerability on this host here. Oh, what are we doing here? We'll take a look at the SSH config by using this vulnerability. So we're just using this server-side request forgery vulnerability to read local web server files. Been wanting to get into SSH to set up my RPI actually. Well, if you if you set up SSH, don't make any common mistakes. Normally, when you set up SSH, you wanna make sure that you're not using passwords to log in, but you're using public key files or public key files. And you want to make sure that everything's nice and secure. And you definitely don't want to configure it so that the root user can log in, because that's a big no-no. So what other things could we check through? I'm aware of what not to do, but not necessarily what to do. No worries, no worries. Okay, so Linux and Windows stuff, operating system stuff. So Signamine mentioned the Apache configuration file. Linux Apache configuration file. So what's that? It's HTTP etc apache2 apache2.conf. That was to find the web root. Oh, I mean we know the web root. Could there be other stuff in there though? I mean, we can look at it, right? It shouldn't be too hard to. It should be publicly accessible. Yeah, okay, so it doesn't tell us very much. Are you doing this standalone? Standalone? Oh, no. We're doing you're trying to access this stuff, right? So this is the bootcamp. So you go to Hackbase, and then inside of Hackbase, it's, what is it? Where is it? Bootcamp. So click on Hackbase, then Bootcamp. So Bootcamp, and then you click on Bootcamp, and then click on Access and Resources. This is where you download your VPN connection key. And then after that, you click on Bootcamp, and it'll give you the information like the IP range. Okay, so let's What other files could we start reading on here? Where would the... There's no login page. If there was a login page, then we could potentially look for some database credentials, but there's no login page on the application. Or at least I don't think there's one. There's no like admin directory or anything. Although I guess we could do one more GoBuster sweep. So we could do GoBuster, look for those PHP pages and all that other good stuff. So PHP, HTML, TXT, zip, and we can look in the appropriate place, gallery.edu.stf. Okay, well, that just locked up my terminal, but I guess we can go back. we can do more stuff in another terminal. It's fine. So the hash cracking, I guess it was not meant to be. Bread? Is that are those bread emotes? BRV bread. That's awesome. That's awesome. But yeah, NT9V. You said that you're doing computer science, right? Computer science. What year are you in? Are you first year, second year? I guess you have to be second year to be in computer science because the first year you don't really get to declare your major yet, right? Okay, let's look back at the notes. So what can we do with just file read? Third year, okay, awesome. Yeah, if you live in a big city, what I recommend is that you go to some in-person cybersecurity meetups. All the big cities are going to have in-person meetups. It's usually going to be called something like DEF CON your area code. So DEF CON 604 for, Vancouver where I live, or DEF CON something something. You can also look for the term OWASP. OWASP, in my case it would be Vancouver because I live around Vancouver, but you could substitute in your own big city name and it'll give you some information about where these groups meet up. It's a good way to start meeting some cybersecurity professionals. My brother put me on early, so I've been interested for a while longer. Awesome, awesome, great to hear. The other thing is whether or not we can access... I don't think we can access other web servers. But just for fun, I'll give it a try. Okay, so let's try... HTTP www.edu.stf, and I think the landing page is called... The landing page is a PHP page, but I'm going to need to double check that. Oops. Okay, so this is... I just need to make sure that this is index.php. Yeah, this is a PHP page. So we'll try accessing it from server-side request forgery. Send that and see if it actually goes through. Maybe try your server. Hold on. I just want no. I mean, we know that server-side request forgery works. I'm just wondering whether or not we can access other other local servers through here. Let's give it a try. Yeah, it is able to access these pages. So these might be able to access the pages that we were not able to access from the other server. So we found another server that had some sort of web application firewall. It was test web server, this one. So if we try to navigate to this normally, it says site is temporary and unavailable, maintenance is in progress, we apologize, etc., etc. But I just want to make sure, is this index.php? This is an index.php page. We'll try accessing this using the server-side request forgery and see if we get a different response. Okay, send it out. Okay, it looks like we got a response, but is it a different response from what we get when we try to access it from the outside? We'll find out in just a sec. So it still says offline. I guess accessing it through SSRF doesn't really give us, it doesn't seem to get us any like special privileges on other servers. Oh, you know what? There was another server. There was another server that wasn't giving us any response. The forbidden URL. Forbidden URL? Maybe? Maybe? Okay, so this one over here, this server on port 443, we weren't able to get a response on this. Maybe we can get a response through SSRF. Okay, so let's do server-side request forgery. So in this case, we're looking for HTTPS. Well, give it a try. What's the worst that can happen? Nothing happens. That's the worst. That's the worst that can happen. Okay, still doesn't work. Nope. Dang it. Okay. So Ronan, we're kind of running out of stuff to look for with server-side request forgery. We've been able to access a bunch of, local files on the web server. We weren't able to find any, anything super juicy like SSH private keys. And it doesn't seem like the server is... It doesn't seem like the server is running... Oh wait, what is the file in PHP that keeps the database creds? PHP database credential file. config.php, right. So we could try looking for a config.php, but I don't think it exists. I'm pretty sure it doesn't exist on the landing on the root directory. What was it? Config.php? Yeah, not here. That doesn't necessarily mean that it's not in the box, but it's not in that directory. I don't know. Okay, so how much more time do we have left? I think I'll work on this for another 20 minutes or so, and then I'm going to have to call it a day. I really wish I could key in the number of minutes instead of clicking on this thing. Okay, final 19 minutes, let's go. Yeah, there's no config.php. We were looking for something else. Let's switch over to 10, D36. Let's take a look at GoBuster 2. Same things. So there's the JavaScript directory here that we could probably get access to it, but we don't know what's in there. We need a definite file name to read it. We can't look at the etc shadow file. Let me check one more time just to make sure that we can't. Say file. The other thing we could do is we could try to brute force. We could try to brute force the SSH, because we have the name of a unique user on the system. So we know there's this web user which is unique to this system. And if we were able to, well, okay, let's try our brute force attack just for fun, because we got nothing better to do. Let's see, let's do some Hydra. The web user, we use wordlessrocku.txt, and I guess just to be polite, we'll turn down the number of threads to like 16 or something. Gallery.edu.stw STF. Okay, so it's recommended does not support password authentication. Does not support password authentication. Okay, well, I mean, if it doesn't support password authentication, that means we have to either steal an SSH private key, or we need to use the web application vulnerability. It's some sort of web application vulnerability to create a reverse shell. There's no other alternative in this case. So how do we do this? Just for fun, I just want to see this myself. Web at okay. So permission denied public key. Okay. So what was the other files that you see inside of SSH directory? LSLA home.ssh So known hosts. Did Webnot have a public key? I mean, do they have a public key? Authorized keys. Okay, so we can try looking at it. So it's home web.ssh known hosts or authorized keys. Known hosts. Send this off. Nope. How about okay, and just for sanity, okay, this works. So, .ssh something something didn't work. Man, what are some other files that could have like something super juicy? I'll try looking again in... So GoBuster's still running here. Okay, so etc. files of all Linux packages. Well, I mean, we don't care about all Linux packages. Default web root directory linux.txt. Oh, you know what? This could be good. This could be good. Let's take a look at this. I mean, it's not that good. Never mind. Zen, hello! Nice to see you here. Not too late. Well, I mean, we're going to be online for another 12 minutes or so, but yeah, if you want to watch what we did today, you can always go back in the VOD. You're on YouTube after all. Okay, so what else we're looking at? Etc. files, graceful security. This is what we used previously, right? Linux and Windows. User agent's operating system name. I don't think we've done this one yet. So this is for a bunch of... You know what? We might as well give this a try. Doing this with... But this is a lot of stuff. It's a lot of stuff. Okay, let's give it a try. So it's FFUF. FFUF. So it is word list here. It is SSRF rec.txt. Okay, let me start. So file equals fuzz. Huh, really? That's what we want. Restream bread, man. Okay, let's run the thing. And size 18 seems to be no good, so we need to filter on size 18. I'm sure we'll get some hits. Okay. Huh, we can get etc. cron tab? Well, it might not be super good, but we'll take a look at the cron tab. Okay, and then yeah, nothing good here. Bash RC, bash completion. When do you plan to do after school for reverse engineering? It might be a little while. It might be a few months. Probably sometime in the new year. I'm gonna say something like spring. It might be like spring of next year. Etc. default SSH Apache 2 cron. So it's actually not all that much. Most of this stuff came back no good. What the heck is etc. shells? Oh, these are valid login shells. Alright. OpenSSL configuration, systemctl configuration. Etc. cron tab. What is bash completion? Doesn't tell us very much. Pam sudo? Pam sudo, Pam password. Magic environment variables. Apache 2 environment variables. Apache 2 configuration, okay. Is this finished? Still didn't find anything, okay. Let's try getting this file. It's called Apache 2 environment variables. Brar says, last night my Discord got hacked by a common Discord hacking group. They get access to the account, they spam. Ronan said, did you check the site library.edu.stf? I think I did. Let me take a look at my notes. Hold on. So library is which one? This one, yeah. So this is the one that's running WordPress. So we're able to upload PNG files, possible file upload attack. I haven't managed to get this one working yet. But Abrar, I'm sorry to hear that your Discord server got hacked. I don't know what this thing is about crypto that Mr. Beast is promoting. It's probably not the actual Mr. Beast that's promoting it. It's probably something or somebody else. But Ronan, yeah, I have taken a look at the at that particular site. Let me take a quick look at it, just because you mentioned it. Ooh. Here. You don't have permission to access this resource. I could have sworn I was able to look at it before. That's weird. $233 is library.edu does. That's odd. Hold on. Maybe I can... Which IP address is this? This is 233. Let me take a look at my notes. Okay. So port 80 is open. Wait. 233. I am looking at 233, right? Yeah. So WP, oh, this is the WP admin endpoint. Let's try this. So WP admin, not found. WP content. I've seen lots of Discord users getting hacked the same way. My question here is, how is a massive amount of users getting hacked by the same group? I mean, I'm not too sure. It's either some sort of phishing attack, in which case there's some administrator on the server who's accidentally clicking on weird links, or there's some sort of undisclosed hack that affects Discord, but I don't know if that's not very plausible. Because if you have some sort of fancy Discord hack, you could report it to Discord and get like a ton of money. You could probably get something like $50,000 or $100,000 for some sort of automated Discord hack. What's their motive? Because they don't change the email or password, they just spam. I don't know how to answer that question. So why is this forbidden? It seems a bit weird. You don't have access to this resource. So is this index.php? This is index.html. This is not index.php or HTML. Here's a funny thing. It doesn't look like I did GoBuster on this. I mean, I must have done GoBuster on it because I found all this stuff, but I didn't record it, which was not good. It was not good of me. Okay, let's do GoBuster over here, and might as well rename this session as well. Okay, GoBuster all the things to library.edu.stf. Look for the PHP, the HTML, the TXT, zip, back files, and GoBuster1.txt. Okay. Cypher says, do you think it's more common for people to get viruses or just wreck their computers because they don't know what they're doing? Okay, let me interpret that question one more time. Do you think it's more common for people to get viruses or to just wreck their computers because they don't know what they're doing? So are you saying that people... Thank you very much for subscribing, Abrar Mahir. Thank you. Define wreck. Wreck is in, like, delete files that they're not supposed to delete or modify files they're not supposed to modify, and then the stuff doesn't work anymore? So I mean, I've definitely messed up my computers pretty bad by downloading stuff I shouldn't be downloading, but that was a long time ago. And I guess the same thing goes for modifying critical files on your computer. Yeah, it's much more common to people to get viruses because of ignorance. Like, they start running binaries that, you know, because they want to crack their games or something. And then that, you know, that downloads, well, that runs virus binaries and stuff on the computers, and then all sorts of bad stuff happens. Anyways, I think I've run out of time. Let's talk about what we're going to be doing next week. So I haven't posted my schedule for next week yet, but well, we're going to be doing streams next week. Let me tell you. But in the meantime, we should probably look for somebody to raid. I'm the only person on the InfoSec streams list that's streaming right now. Okay, let me check who's on Twitch. I used to be so good about getting viruses. I mean, you could be good at getting viruses again. It's very possible. Very possible. Okay, let's go ahead and raid into Moohoodles. Moohoodles is always doing some fun space stuff. I'll copy the clean link. Just a second. Let's see what she's up to. Just install LimeWire. You get all the viruses you want. Yeah. Download those MP3s all over again. Looks like Moohoodles is doing some gaming stuff. Okay, so we're not particularly vibing with gaming stuff. Let's try the science stream. Science streams is always doing some science-related stuff. Okay, what do we got? Linus Tech Tips. Is he on right now? I knew what you're talking about. Okay, so it looks like Science Streams is here, and we can raid into that channel. Linus is live at the moment. I don't think Linus would really appreciate, like, you know, the number of viewers we're sending his way. Let's raid into Science Streams. Alright, but thank you very much for everybody who participated today. Everybody giving us suggestions in chat. Very much appreciated. We'll be back on Monday. I hope everybody has a great weekend. And we'll be back next week with more Hack in Action on Mondays, Wednesdays, and Fridays. Alright, when you arrive at the science stream, please give this raid message, OSFrog, hip hop hack OSFrog. I would really appreciate it. Okay, everybody ready to raid? Have a great weekend. We'll see you next time. 3, 2, 1. HackerFrogs out.